Hello, and welcome to Introduction to User Experience. I'm Mark Newman. I'm an associate professor in the School of Information here at the University of Michigan, and I'm very excited to be offering this course and serving as your instructor. User experience is an exciting and growing field in which experts apply research and design methods to create products that people love. In this course, I'll be introducing you to what user experience is and what it's all about, and showing you a process that you can use to ensure that products that you're creating or trying to improve will deliver a great user experience. In this course, you will also dive into UX research and design methods that you can use right away. And they'll also give you an idea of what it's like to work in this field. Once again, welcome to the course. I think you'll have a great time and learn a lot, and I look forward to seeing what you can accomplish. We've all had good and bad experiences with products that we use in our daily lives. So let's think for a minute about what makes an experience good and what makes an experience not so good. When we think about a good experience, what are some words that we might use to describe it? We might say that a product is useful and that it helps us accomplish something that we need to do. We might say that it's easy to learn. It's easy to figure out how to get things done with it. It might be helpful. It helps us accomplish something that's important to us. It's accessible. We can access it on the devices and in the places that we need, and using the motor and perceptual capabilities that we have available to us. Perhaps it's attractive. Perhaps it's pleasant to look at and pleasant to interact with. It might even be, in some cases, fun to interact with. It might help us to feel more connected to other people or to the organization or the company that's providing the service or the product. Dare we dream that a product could be delightful and that the experience could leave us feeling better than we did when we started using it? And in the end, a good user experience is satisfying. What about a bad user experience? Well, we might think of a bad user experience as being one that's stressful, one that perhaps we don't really know how to use the system to do what we need to do. Perhaps that's because it's confusing. We're not sure which way to go or how to use the different features that are available. Maybe it's ugly. Maybe it works okay, but it's just kind of unpleasant to look at, or it's inelegant. It's not enjoyable. Perhaps it's distracting. Perhaps it forces us to do things or engage with features of the system that are not part of what we're trying to accomplish. And therefore, maybe it's inefficient. It takes too long to do things, and maybe it's tedious. It forces us to re-enter information that we've already given it or that it should already know. Some systems can even be condescending. They force us to do things in ways that don't take advantage of our knowledge and our skills and our abilities. Some systems can feel inconsiderate. They don't allow us to do things the way that we want to do them. They force us to do it the way that their designers have decided things should work. And in the end, a bad user experience is often frustrating. We leave the experience feeling worse than we did when we started. Well, why does it matter? Of course, we'd all like to have good user experiences, and as designers of products, we would like to deliver good experiences. Well, there's more to it than that. When you're designing a system, you're trying to solve a problem that your users have. But at the same time, you're trying to accomplish goals that drove you to design the system in the first place, which might be getting people to visit your website or buy your product or use your service to buy other products. And it's important that your users experience success so that you can meet the product goals. Additionally, if your users experience success, they're much more likely to come back and do it again. And they're also much more likely to recommend your product to others, to create a kind of virtuous cycle where not only are they coming back and using the system and doing whatever it is that you want them to do, but they're getting other people to try it out and do those things as well. Let's go through a couple of examples here. So let's take the example of Amazon huge retailer, online retailer that sells pretty much everything under the sun. Why is it important to Amazon that users have a good experience when they come there? Well, the answer initially is pretty obvious. Their goal is to get you to buy stuff through Amazon, and if you're not successful at buying stuff, they won't be successful as a company. They also want you to enjoy the stuff that you get. They want you to have a successful experience, not just in the process of buying it, but with actually using whatever it is that you get. So they want to make sure that you have enough information to get the right thing. And they do this through recommendations and reviews and product information and all kinds of things like that. If you enjoy the experience of using the system and the experience of using the products that you buy through Amazon, you're much more likely to come back again and buy more stuff in the future. And you're also more likely to recommend Amazon to others when they need things for their own lives. Let's take a really different example. This is the website of the city of Ann Arbor, which is the city where I live and the city where the University of Michigan is located. What are they trying to accomplish? Why is it important for a municipal website like this to deliver a good user experience? Well, they built the website for a reason, and one of the primary reasons they built it is to help citizens find information about how the city works. Let's say I need to figure out how to pay my parking ticket, or report a pothole or a broken streetlight, or find out what construction is going to be happening that might affect my commute to work. By effectively delivering information, the city website can help the residents of the city understand how the services work. They can understand when their trash pickup day is and how to report problems when they arise and how to use city services more efficiently. Because at the end of the day, the goal that the city would have for a site like this is to streamline the services that they offer, to make it more efficient, so that fewer people have to pick up the phone and call somebody or come into a city office and use more time-consuming ways of getting things done. And like with any other good user experience, if one user has a positive experience, they're much more likely to recommend it to others when they have similar needs. So let's look at one more example, and this one is quite different than the last two that we looked at. This is a digital glucometer, which is a device that's used by people that have diabetes to measure their blood glucose level, which is very important for maintaining their health, for determining what it's safe for them to eat, whether they need to take an insulin dose to balance their blood sugar, and so on and so forth. So why is it important for the manufacturers of this device to ensure that users have a good user experience? Well, a critical goal with a device like this is to improve its users' health, to make sure that users are successful at finding out what their health status is so that they can make the right decisions in their lives. Of course, it's very important with a product like this to make sure that they do no harm. So err on the side of safety where other design considerations might be in tension with each other. It's also important not just to convince users that this is a product that will give them a positive user experience, but also to convince the health providers and insurers that this is a safe device, but also a device that will result in a better health outcome for the people that need to use it. And again, like with other types of products, if the users are successful at having a positive user experience, they're much more likely to recommend it to others who have a similar need. When we talk about the user experience, we're talking about really the experience that people have when they interact with your product across the board. That means, of course, using the product, but it also means other things like choosing the product from among the myriad of other products that might be out there, whether it's other websites or other apps that are on the App Store. Acquiring the product. How do they actually go from selecting the product to getting it in their hands so that they can actually use it, whether it's accessing it via a web browser or downloading it or purchasing it in the store. It also includes the experience of learning to use the product. So getting from that point of acquiring it in the first place to actually being productive and experience success with it. User experience also includes fixing the product. Not everything works out of the box. Perhaps it's because of a problem that somebody's having understanding how to use the product, or maybe the product is broken and it needs to be fixed. So how do they go about getting help when they're stuck or when they have a problem? User experience also includes upgrading the product or purchasing the next product or starting to use the next version of the product and so on and so forth. And it includes many other things as well, and these are just a few examples. So why is user experience hard? We know what a good user experience should look like. We know what we want to avoid, but why is it not always easy to do this? Well, one of the reasons that it's hard is that you, as the designer, are not the user. Even if you are a potential user of this product, you don't represent all the users. And it's very important to go out and understand who the users are, what they need, how they work, so that you can design effectively for them. Another reason that UX is hard is because most of the time in UX, we're dealing with software. We're dealing with computer-based interactive systems. And computers think differently than people do. So translating what works and what's easy to do for computer programmers and what's easy for computers to do into what makes sense for users is a big part of what we do in UX, and it's challenging. We often get it wrong the first time, and we have to go through many cycles to get it right. And the products that we're designing are usually quite complex because of the fact that they're software-based, and it's so easy to add new features. And so helping keep a focus on the user experience and what users really need is a critical part, and it can often be very challenging, especially when designing larger and more complex systems. Fortunately, in user experience, we have techniques that we know work to help make user experience easy. First, we follow an iterative prototyping process. As I said just a minute ago, we usually get it wrong the first time. So rather than trying to get everything perfect right out of the gate, we try to use techniques that allow us to fail fast and learn from our mistakes. We do that by applying user-centered research and design methods, and we have a whole set of these that we know will work to help keep the design on track and make sure that we're designing something that's going to end up delivering a good user experience in the end. It helps to understand a bit about human behavior. You don't need to have a degree in psychology in order to design good user experiences, but it is helpful to know a little bit about how people work and what we know will help them accomplish what they need to accomplish. And ultimately, we do all of these things to allow us to apply common sense. By following an iterative prototyping process that uses user-centered research and design methods and knowing a bit about human behavior, we're in a much better position to use our own common sense to make good decisions when designing systems. We all know what a good user experience looks like and feels like, but it can be challenging to design products that deliver that good user experience to the people that use it. Fortunately, we know a few things that we can do to make it a lot easier on designers to ensure that the product that comes out the end delivers a good user experience. First, we follow an iterative prototyping process where we design multiple versions of the product, each time getting better and better. We apply a user-centered research and design approach to make sure that we're keeping users' needs and users' capabilities in focus throughout the process. We need to understand a bit about human behavior to make sure that we're designing things that are likely to work and avoiding things that are likely to fail. And we make sure that we use a process that allows us to apply our common sense to ensure that the product is moving in the right direction. The reason that we iterate is because we know that we're not going to get it right the first time. We want to fail as fast as we can, get it wrong as quickly and as often as possible so that we can learn from our mistakes and get it less wrong each time. So that as we're moving through the process, we're designing a product that's getting better and better and doing a better job of delivering a good user experience. The iterative design process that we apply in user experience can be thought of in this way. We think of it as 3 phases involving assessment, design, and building. So in the assessment phase, initially, what we're doing is we're assessing what users are currently doing and what their needs are so that we can understand the design space and the problems that they're facing so that we can design products that will address those needs. In the design phase, we take what we've learned in the initial assessment and come up with ideas, lots of ideas for how we might deliver a product that solves the problems that we've identified in the assessment. In the build phase, we take those design ideas, or a subset of those design ideas, and we build them into prototypes or some kind of representation that we can use to communicate a particular idea so that we can then use it to get feedback on whether that idea is headed in the right direction or in the wrong direction. And we can then apply assessment methods like user testing or formal inspection methods to see if that prototype is leading towards a good user experience or a bad user experience. And then we take what we learn from that and we repeat it all again. We go back to the drawing board, we design new ideas, we build new prototypes, we perform new assessments, and we continue this until we're satisfied that the product is ready to go. Another way to visualize this process that helps to show how the process can be iterative but still progress towards an ultimate endpoint is to view it as a spiral, where we start on the outside with the assessment phase and we traverse around the spiral through the design, build, and assessment phase multiple times until we ultimately reach the center, which is the endpoint, the final design. The other thing that's nice about this visualization is it kind of gives you a sense of you're zeroing in on a target and you're getting closer and closer as you progress. So the design is getting more and more finalized and hopefully better as time goes on. So we can see from this that an iterative design process includes both user experience research as well as user experience design. And it's critical that both research and design are used in a balanced way to iterate towards a successful solution. So for UX research, there's a set of methods, well-known methods that can be applied to understand user needs and evaluate prototypes as they're being developed. So for example, we often conduct interviews to understand more about users' needs and how they currently do things. We conduct observations to actually watch what people do and how they do it to understand things that they might not be able to tell us very effectively through interviews. Sometimes we conduct surveys, especially when we're wanting to reach a very large audience and we need to understand characteristics and behaviors and attitudes of that large audience, and we're not able to reach out to every member of that audience because there's just too many of them. We use user testing to take a prototype or a system that we've developed and figure out whether or not people are able to accomplish what they need with that prototype or system. We also apply a range of inspection methods where we can use best practices and knowledge about what works and what doesn't to take a close look at a prototype or a representation of a system to determine whether it's on track for delivering a good user experience or not. We also apply a set of design methods throughout the UX process. So for example, developing personas and scenarios and user stories to represent the types of people that need to use the system and the types of things that they need to be able to accomplish with the system. We also use sketching and ideation to generate lots of different possible solutions so that we know that we have a lot that we can choose from so that we can get the best ideas out there. We use storyboarding to think through what the interaction with a system might be so we can see whether it makes sense and whether that's going to be something that results in a good user experience. We use mapping and navigation design to map out all the different things that you can do with a system and make sure that they all make sense together. We conduct comparative research where we go out and look at the competition or other examples of products that are trying to accomplish similar things to try to understand what are the best practices out there and what are the things that we might want to avoid. And we build multiple different types of prototypes, from low to middle to high fidelity prototypes throughout the process to put those design ideas into a form that we can use for getting effective feedback and using for assessments like user testing. And as I said, it's important to understand a little bit about how people work so that when we're going through that design and prototyping process, we're creating stuff that's more likely to be effective in the end. So understanding things like, well, what can people perceive? How does the human visual system work, for example? So how do people extract information from visual stimuli? How can you design a screen or a web page so that people can actually understand what's on it? how do people do things? How do people act in the world? How do they decide how to act in the world? And how do they process information about the results of their action? How do they know if they're going in the right direction or if they need to take a different path, so that we can design systems that guide people in the direction that they need to go? And how does emotion play a role? Or how, when, and why does emotion affect decision making? And what role does emotion play in user experience? So that we can design systems that produce satisfying, positive emotions in our users. And finally, we want to set ourselves up so that we can use our common sense to design systems that will work. And a process that puts you in touch with user needs and practices in user responses to possible designs through user testing and other methods will allow you to see what works and what doesn't. So that's how we make user experience easy. We make it easy on ourselves as designers of systems to produce products that deliver a great user experience. We follow an iterative prototyping process. We apply user-centered research and design methods throughout the process. We understand a bit about human behavior so that we can steer the process in a positive direction. And we set ourselves up to be able to apply common sense so that we are constantly moving towards a product that will, in the end, deliver a great user experience. So we all know what a good and bad user experience feel like, and we can think of lots of words that can be applied to both of those situations. A system or an experience can be helpful, it can be easy to learn, it can be attractive, it can be fun, or it can be stressful and ugly and condescending and tedious and frustrating. So how do we keep all of this in mind when we're designing? How do we focus our design so that we make sure we're avoiding those qualities that we don't want and moving towards the qualities that we do want? Well, Frank Guo, writing for UX Matters in 2012, offered this simplified way of looking at user experience that I think is really useful. He suggested we could break down user experience into 4 major components. It's value, usability, adoptability, and desirability. So when we talk about value, we're asking, is this system or is this design useful for people? Does it accomplish what they need it to accomplish? And is it better than the alternatives? So as an example, we can think of VisiCalc, which was developed in the late 70s and was the first software spreadsheet that was used by lots and lots of people. And it was an enormous success because it allowed people to do something that they simply couldn't do before, which was to be able to update a whole network of different formulas and see the results immediately. So it allowed people to rapidly explore different financial calculations and so forth in a way that simply wasn't possible before. So it delivered enormous value for people that needed to do these kinds of calculations, and it was vastly superior than anything else that was out there. By modern standards, it wasn't necessarily a huge usability success. In fact, when competitors came along a few years later, like Lotus 1-2-3 and Microsoft Excel, they eventually wiped out the market for VisiCalc because they were able to offer superior usability and other qualities that were superior. However, because VisiCalc initially offered functionality that didn't exist, it was able to be incredibly successful. When we talk about usability, we're asking, can users do what they need to do? So assuming we have the value right, are people able to actually realize that value? An example of a product that got this wrong was the Motorola Rocker, which came out in the early 2000s, 2004, I believe. It was actually several years before the iPhone, but it was the first phone that integrated or attempted to integrate MP3 playing functionality, and it actually connected to the iTunes store that was run by Apple. However, its usability, by all accounts, was awful. People couldn't figure out how to use it. They couldn't figure out how to access the music playing functionality, and it had other strange limitations, like only being able to show the first 100 songs that you had stored on the phone, even though there were other songs that were on there, perhaps thousands of other songs. As a result, even though the value was there, this was something that there was definitely a consumer need for, as demonstrated by the iPhone a few years later. The usability prevented this from being a success, and the product ultimately failed. Desirability refers to the extent to which a system is fun, attractive, and pleasant to use. So sticking with a similar example to the rocker, the iPod, when it came out in the early 2000s, was an enormous success. When the iPod came out, it offered a striking new design that a lot of people just loved and found really fun and engaging to use. In particular, the scroll wheel was a whole new way of interacting with a device like this, and people really found it to be intuitive and elegant and an enjoyable way of interacting with this device, and that contributed to the success. And finally, adoptability refers to how easy it is to find and start using a system or a device. And to illustrate this, I'll show an example of a service that offers a very, very nice initial use experience. So this is the website for Duolingo, which is a service for learning a new language. And this is the screen that you see the first time you come to Duolingo and you haven't ever used it before. So very clear instructions. We get started. And the first thing it asks is, what language do I want to use? Well, let's say I want to learn French. It then asks me how serious I am about it. So I don't really know. I'll just say I'm regular. So next it asks me, am I new to French? Or if I already know some French, let's say I'm new to French. And I'm immediately starting to learn French. It asks me to select the translation of the woman, and I start to engage in the learning process. So you'll notice it didn't ask me to create a username or a password or enter my credit card or any of those other things. It just got me right into the system and allowed me to start using it. As I go forward, at some point, it does ask me if I want to create a profile so I can save my progress and things like that. But it succeeds on the adoptability criteria by making it very easy for me to get in and get started without having to go through a lot of other stuff that's actually not interesting to me. The basic methods that we use in user experience research and design are aimed at helping us address all of these attributes of user experience. So the methods that we use for understanding users, for designing and prototyping systems and evaluating designs can be applied to questions around the value, usability, adoptability, and desirability of a system. So for example, if we think about user experience research, and think about two main types of user experience research activities that we typically perform, activities around understanding users and activities around evaluating designs. So when we're asking questions about the value to users, in the understanding phase, we ask, what is it that users need? What does our system need to provide for them? And when we're evaluating, we ask, does this design fulfill the needs that we understand? When asking about usability, in the understanding phase, we need to understand, how do they do it now? How do they accomplish the tasks that our system is going to support in their current lives and using their current systems? Once we're evaluating designs that we've produced, we ask, can they get it done? Can they do those tasks with this system that we've designed? When looking at desirability, in the understanding phase, we need to understand, what do our users desire? What do they look for? What are their turn-ons and what are their turn-offs? And when we're evaluating designs, we can ask, is this design appealing? Does it have those qualities of being fun and delightful and elegant that we associate with desirability? And finally, when looking at adoptability, when we're understanding users in the initial phases, we can ask, where do users look for things and how do they make sense of things when they first start to use them? And when we're evaluating our designs, we can ask, can users find and access this system based on how we're planning to provide it to them? The iterative design process that's at the heart of user experience research and design is your guide for making sure that these different components of user experience are realized in the product that you're designing. So to wrap up, user experience is multifaceted. It's not just about one of these things. It's not just about usability or elegance or desirability. The basic UX methods that we are covering in this course and in other courses can address these different UX concerns. And most importantly, let the process be your guide. It's not something that you can get right out of the box, but you need to follow an iterative process, asking questions all along the way to make sure that at the end you come out with a product that delivers a great user experience. So what do we mean when we talk about design in UX? Well, I'd like to start by thinking about how the term design is used in common, everyday ways. And I'd like to do that by looking at what happens when we do a search on Google Images for design. Well, what we see are a lot of visual images that are essentially decorations of some kind. If we scroll down, we can see lots of graphical images and some tools that are used for producing graphic images. And so commonly when people talk about design, they talk about how something looks, maybe what decorations it has, what form it has. However, this is a very narrow and specific use of design. Steve Jobs once said, most people make the mistake of thinking design is what it looks like. People think it's this veneer, that the designers are handed this box and told, make it look good. But that's not what we think design is. It's not just what it looks like and feels like. Design is how it works. Charles Eames, a well-known mid-century furniture designer, said, design is a plan for arranging elements in such a way as to best accomplish a particular purpose. So from these two quotes, we start to get a picture of design as being first a plan. So a design is not the final product, it's not the outcome, but it's a plan for producing that product or that outcome. And it's a plan for arranging elements. And those elements will depend on the type of product that it is. So the elements could be gears and pulleys, or it could be wood and leather. It could be lines and swatches of color on a page. Or in the case of UX, it could be things like text and icons and buttons and images. A design is a plan for arranging elements to accomplish a purpose. So there is a purpose that this design is supposed to accomplish and is supposed to help the users or the consumers of the design to accomplish. And ultimately, a design is mostly about how it works and the functionality, and not just about how it looks. Of course, it also includes what it looks like and what it feels like. The well-known designer and architect Buckminster Fuller said, when I'm working on a problem, I never think about beauty. I only think about how to solve the problem. But when I've finished, if the solution isn't beautiful, I know it's wrong. So here we see an echo of Steve Jobs' point that design is not strictly about beauty, but we see an emphasis on design being about solving problems. So this brings us to our first major point, that design is about solving problems. So what do we mean by solving problems, and what are the kinds of problems that design can solve? Well, let's look at an example. This is Zappos, which is an e-commerce site that primarily focuses on selling shoes. They sell lots of other clothes now, but they started out selling shoes. And so what is the problem that a product like this is trying to solve? Well, it's trying to solve the problem that some people need shoes. Well, that's simple because it so happens that the creators of Zappos want to sell shoes. So this should work out perfectly. However, the problem is a little bit more sophisticated than that because there's lots of ways that people can get shoes. They can go to a shoe store. They can go to lots of other websites to get their shoes. So maybe we need to understand the problem a little bit better. Well, so maybe it turns out that what consumers need is shoes that they can acquire conveniently without having to go out and go shopping and spend the time that it takes to do that. They want to receive them fast. They want to be able to get them within a day or two. They want to be able to find shoes that are in their style that they actually like, and they need it to be reliable. They need to be sure that when they invest the time in going on to Zappos, that they're going to have a successful outcome. Maybe it turns out also that people don't know exactly what they want and they need inspiration. They need to be able to be led to the choices that are going to be satisfying for them. And oh, by the way, there are a lot of different consumers who have different tastes and we're all different. So this can lead to a more precise articulation of what the solution to this problem of delivering shoes to consumers might consist of. So now, as the creator of this product, I might be able to articulate what I'm trying to do as I want to be able to sell shoes faster, more conveniently, with more selection, in a way that's more personalized than the alternatives. I want to do it in a way that's fun and inspiring for people so that they have a positive experience and that they end up finding shoes that they enjoy and that delight them. And I want to do this across many demographics and styles. So what we've seen here is we've gone from a very simple high-level problem statement and we really unpacked it to understand more specifically what this product needs to accomplish. So we've not only understood the problem better, but we've understood better what the form of a solution needs to be. The design researcher Brian Lawson, who studied how designers work across many domains, across many years, has said that design is as much a matter of finding problems as it is solving them. And I would add, it's about articulating problems in such a way that you can understand what the form and the criteria of a solution ought to be. So we can look at a very simplified version of the process that we follow when we're designing. The first step is understanding the problem. And as we said, making sure that you understand the problem well enough that you can envision what a solution would look like. What would the solution have to have in order to actually solve that problem? At that point, you can generate possible solutions. You can start thinking about different possible ways to solve that problem. And the goal here is actually to produce lots of different solutions that could be candidates for solving the problem. Given those possible solutions, the next step is to analyze systematically the solutions against the criteria that you established for what a solution ought to have and select the ones that are the most promising that can be elaborated and brought forward to the next phases. The next step is to embody those solutions, which means to build some kind of a prototype that can be used for really understanding how this solution would work, and that can also be used for assessing whether or not we're moving along the right track. At the assessment phase, what you want to do is you want to find new problems, ones that you missed the first time around. Maybe you missed important requirements or you missed important constraints. And now you're going to go back to the beginning, understand those problems, generate possible solutions, and so on and so forth. So to look at an example of how this all works, I'd like to show you a pretty cool project that I just came across recently. It's called 50 Problems in 50 Days, and it's this British designer named Pete Smart who traveled all over Europe and set as a goal for himself to do 50 designs in 50 days, starting with understanding a problem in the morning, working through solutions, and coming up with a prototype of a solution by the evening. So one that I like is day 29. And he was staying at a hostel in Amsterdam. And he observed that at his hostel, the staff sometimes have guests who can't speak a language that they understand. So there's this communication problem between the staff at the hostel and the guests. So today's challenge, he said, was work with the hostel staff to develop a system to assist communication. So he started out by sitting down with the staff and asking them to think of questions they are often asked by guests and have them write them down on Post-it notes and created just a huge number of the types of questions that they often have to answer on a day-to-day basis. So this was part of understanding the problem and understanding in a more specific way, going from the general problem of communication to say, well, what are the specific types of communication we need to address? He went forward from there to organize those into different categories of questions, saying, well, are there themes or are there patterns that we could leverage when trying to come up with design solutions? And from that, was able to organize a communication architecture to summarize the flow of interactions with guests. So how do they go about figuring out what the question is and what type of answer the guest is looking for? And further went through to categorize these into key themes and actually asked the hostel staff to work with him to draw some of the key themes such as luggage, checkout, train station, breakfast, and so forth, and look at how those could be communicated through pictures, since the problem is that people don't have a shared language that they can use to talk about these things. He then engaged in rapid prototyping, so basically sketching out and trying out different ideas that could be used to facilitate this kind of communication. And then ultimately iterated through those to come up with this particular prototype, which was a book that could be used to facilitate communication. And the way it works is a guest could take the book, they could point to whether they had a question or a statement, what was the type of question that they were trying to ask? Was it about when something happens, why something happens, where it is, or about the hostel staff themselves? And then from there could go on and ask more specific questions using these pictorial representations. So in that simple example, just a one-day, very short example, we saw all of these steps, except for maybe the last one, taking place. Understanding the problem, generating possible solutions, analyzing and selecting from those possible solutions, and embodying those solutions in a way that could help both the designer, the hostel staff, and potentially other people assess whether or not it actually solves the problem. From there, you would ordinarily go on and iterate and try to refine and come up with better solutions based on what you learned from that. In some of the other lectures, we've talked about the iterative design process that we use in UX research and design to come up with products that deliver a great user experience. And I just want to point out that this design process that I've just described is aligned with the process that we've been talking about. So when we talk about understanding the problem, that's aligned with what we've been calling the assessment phase, where we understand initially what it is that people are doing, what works and what doesn't for them, and then using that to understand what problems we're going to solve in the design phase. Generating possible solutions is what we do during that initial design phase to try to explore the space of possible solutions. And towards the end of that design phase, we analyze and select the most promising solutions. In the build phase, we embody those potential solutions in the form of prototypes that we can then use with UX research methods to assess and find new problems that we can use in the next phase of design and build. So what I've described here is actually a general design process. It can be used for designing anything from a tube of toothpaste to an aircraft carrier. So what is it that's special about UX design? Well, a couple of things. One is that the experiences and the systems that we're building are interactive, which means that they're time-based, they occur across time. They're based around action response rules, and getting those rules, what happens when a user does X, is one of the critical things that we're focusing on and what it is that we're trying to design. So to break that down more, thinking about designing action, that's about designing the command options or the things that users can do. And when thinking about the response part of that equation, it's about what information is presented and what new commands are available when a particular command is invoked. And as a result, in UX design, where we're dealing with interactive systems, we're often contending with complex system behavior, which drives us towards this focus on usability. How can we make sure that people can navigate these complex systems in order to be able to accomplish the things that they need to do? In UX design, context is critical. So understanding how and when and why people are using and interacting with our systems is critical to getting the design right. So we need to understand the other interactions that people are having with other systems, with other devices, with other people, and the other things that they're doing when they're trying to interact with our systems. What other activities are they engaged in at the same time? And what other people are involved? So looking at this design process that I introduced a few slides ago, and mapping it onto the UX design process, we can see that understanding the problem becomes very much about studying users and the tasks that they're trying to accomplish and the context in which they're trying to accomplish them. Generating possible solutions takes the form of sketching different design ideas, storyboarding to show how an interaction unfolds over time, wireframing specific screens, and so on and so forth. Analyzing and selecting among the design solutions becomes not just about applying the criteria of the design problem as we've understood it, but also applying UX criteria. What is it that we know about what delivers a good user experience and what drives us away from that? Embodying the solutions is going to be about building prototypes, and we'll talk more about the different types of prototypes that you might build. And assessing and finding new problems with those prototypes is going to be based around applying specific UX research methods like user testing to be able to understand what those problems might be. So to sum up, the design process, and we'll be talking about this more in other lectures, is about understanding the problem, generating possible solutions, analyzing and selecting from among those possible solutions, embodying them in a prototype, and then assessing them to see whether we're on track or not, and finding new problems that we need to solve in the next phase. Prototypes play a central role in UX design. What do we mean when we talk about a prototype? Well, Bill Moggridge, co-founder of the prominent design firm IDEO, described a prototype as a representation of a design made before the final solution exists. And throughout the course of a UX design project, you'll typically create many prototypes on the way to producing the final design solution. So why do we prototype? Well, there are a number of reasons that we prototype in UX design. One is reification. This is a term that means to make something real or make something concrete. When we prototype, we make our design ideas concrete so that we can test them out and figure out if they're going to work. We prototype to support reflection. So by making things real, we can reflect on whether they're meeting the design goals that we have or whether they're taking us in a different direction. A critical role that prototypes play is facilitating communication. So by making something concrete, by embodying it, we can then bring other stakeholders into the conversation to figure out if the design idea is going to work. And prototypes facilitate assessment, which of course is critical in the UX process. So by creating embodiments of our design ideas, we can use them in user testing or get feedback from users as a way to determine whether they're going to satisfy user needs. Prototypes can take a lot of different forms. So that notion of a representation of design can really mean a lot of different things that we might produce during a UX design process, ranging from just a verbal description of a design idea to a sketch or a storyboard or a flow diagram to a physical model, a video, a specification. It can mean lots of different things. But usually in UX, when we use the term prototype, we're talking about a representation of the system as it will be experienced by end users. And we typically produce prototypes at multiple levels of fidelity, from low fidelity to middle fidelity to high fidelity prototypes as the design process progresses. And typically in a UX design process, we will be increasing the fidelity of our prototypes over time. So starting early in the process, we'll produce low fidelity prototypes, which are very cheap to produce, but don't really represent what the system will look like in the final version. As we progress farther, we might produce prototypes of increasing fidelity, so mid fidelity and then high fidelity prototypes as we go closer to the end of the design process. And one of the reasons for this is that the cost of producing each of these prototypes is going to increase. And we want to make sure that we've worked out as many of the problems and as many of the design ideas as possible while working in a cheaper medium before progressing to things that are going to cost more, require more effort to produce, and box us in more in terms of the design decisions that we're able to make. So let's go through these different types of prototypes. So a low fidelity prototype is a prototype that we create to address the functionality of the system, to make sure that the system does all of the things that users need, the basic organization of those functions, how you get from one function to another, how they're integrated, and the task flow and coverage. So how do you actually support the tasks that users need to do, and are we supporting all the tasks that they need to do? At the same time, low fidelity prototypes ignore things like graphics, like the colors and fonts that are going to be used. They don't involve any programming. They're often made on paper so that they can be created cheaply and thrown away when they're not needed anymore. And they don't use real data as a result. As we progress through the design process, we'll need to resolve some of these issues, and so we'll move on to other forms of prototypes like mid-fi prototypes. So these prototypes would address all of the concerns that low-fi prototypes address, like functionality and task flow, but start to also look at concerns like the layout. How specifically are all of the different fields and controls going to be laid out? They might start to address some of the issues of interactivity. So how does it actually feel to interact with the system? And how do you navigate from one part of the system to another? Still, at this point, we would be ignoring things like the graphics, the specific fonts, the colors, the images. There would be little to no programming involved depending on the tools that are used. And again, we would not really be interacting with real data. We'd be using fake data to fill in for the data that the system would actually use later. And then towards the end of the design process, when we're pretty sure we have the basic idea of the design right, we would produce high fidelity prototypes which would tackle some of these concerns that we haven't addressed in the mid and low fidelity prototypes, like graphic design, some more interaction details like maybe animations, and more realistic data that would map what users would actually be interacting with. Still, a high fidelity prototype is not the final product. It would probably not involve the back-end programming that would be required, and it might not have complete functional coverage. It would be focused on the task of that particular prototype is supposed to accomplish, whether that's to support a user test, to support communication with stakeholders, and so forth. An article by Lim, Stolterman, and Tenenberg introduces the economic principle of prototyping. They say that the best prototype is the one that, in the simplest and most efficient way, makes the possibilities of a design idea visible and measurable. And this can be applied in the design process by choosing the prototype that is most appropriate for the phase of design to answer the questions that are critical at that time. So early in the process, you're concerned with functionality and task coverage, and you're less concerned with the details of how it's going to look and feel. Later in the process, after you've established the basic functionality, you're going to be more concerned about those issues. And that's why we progress through different levels of fidelity as we prototype. The main reason that we do this is we want to avoid premature commitment, which is investing resources like time and money in design ideas that are going to turn out to be a dead end. When we do that, not only do we waste money and effort, potentially exhausting the project resources and running out of time, where we might end up being stuck with a bad design or a design that isn't as optimal as it could be, but also we end up investing in such a way that makes it very hard for stakeholders to let go of the ideas that have been developed and invested in. So it's difficult to let go of those cognitive and emotional commitments that stakeholders make once they've invested significant time and resources into a particular design direction. By focusing on low fidelity prototyping early in the process, you maximize the number of times you get to refine your design before you commit to code or manufacturing or whatever it is that you're going to do to produce the product for distribution. Low fidelity prototyping uses lightweight materials that are quick, cheap, and easy to change, unlike software or hardware. And our friend Bill Moggridge said of low fidelity prototypes that they are not precious and therefore invite more honest critique. So people are more willing to give honest and open feedback on something that they perceive as not being finished or not being final than they are when they see something that looks like a lot of work has been put into it. How does prototyping fit into the UX design process? Well, before you can build a prototype that reifies your design ideas, you need to go through the process of first assessing current needs and understanding the design problem that you're trying to solve, establishing guidelines and constraints for what a good solution would look like, and developing things like personas, scenarios, user stories, requirements, and so forth to guide the design process. You also need to go through the process of designing solutions through ideation, sketching, selection, and synthesis. And after developing a prototype, you're going to use it to assess whether you're on the right track or not. You might do that through user testing or through inspection methods or just through getting feedback from different stakeholders. And then after that assessment, you'll go through subsequent design processes and more prototyping and continue around this cycle until you're satisfied with the product. So to sum up, prototypes play a central role in the UX design process. They embody design concepts to facilitate our ability to think more clearly about them, communicate with stakeholders and get feedback, and use them in assessment methods that come from UX research like user testing and inspection methods. UX designers do a lot of sketching throughout the design process. What do we mean when we talk about a sketch? A sketch is a cheap, rapidly constructed representation of an idea, and it can take many different forms, as you can see here. The qualities of a sketch that are important for the design process is that they're quick to create, they're timely, they can be inserted into the design process in multiple different ways, they're inexpensive, they're disposable. You don't make a commitment to them. You can get rid of them if they don't work. They're plentiful. You can create lots of them, and often that is what you want to do. They involve minimal detail, so you don't spend a lot of time working on details that are not important to what you're trying to think through or what you're trying to communicate at a particular stage. And they allow for ambiguity, so they facilitate conversation about other design possibilities without locking people into thinking about particular solutions. Bill Buxton has talked a lot about sketching and its role in the UX design process. And he says sketching in the broad sense is an activity, not just a byproduct of design. It is central to design thinking and learning. And sketches are a byproduct of sketching. They are part of what both enables and results from the sketching process. But there's more to the activity of sketching than making sketches. And I think what's really critical here is thinking about the process and the goals of sketching as being different from the output, which are the sketches. So why sketch? Why engage in this activity of sketching? Well, one reason is it allows us to reflect. By putting our ideas out there in a quick and inexpensive ways, we can reflect on how they work and whether they actually make sense. They allow us to explore rapidly a whole set of different ideas that might be very different or might be similar, and we can very quickly explore an entire design space. And sketches allow us to communicate quickly and in a way that's appropriate to the stage of the design process, especially when we're exploring ideas, trying to get feedback on what the right way is to go. How should you go about sketching? Well, first, you want to use pencil and paper or maybe a whiteboard. Computer-based tools are going to force you to deal with all of these details like colors and fonts and precise layout that aren't really appropriate for the sketching activity. You want to be able to go fast, and you want to not focus on perfecting the individual sketches. Rather, you want to focus on making lots of sketches, sketching lots of different ideas. It's also important to realize that you don't have to be good at drawing to produce sketches that are effective for reflection and communication. When we sketch in UX design, there's several different things that we might think about sketching. One is sketching the problem, trying to better understand the problem that you're trying to solve. So how would someone experience this problem? And you might do this through showing storyboards that depict somebody experiencing the problem. You might also sketch the solution. What would it look like for the problem to be solved? And you often are going to be sketching the system that would be needed to help solve that problem. And all three of these will help you understand the design space, understand what the solution ought to be able to accomplish, and what a system would have to look like in order to solve that problem. A closely related idea in the UX design process is the notion of a prototype. And this can be confusing sometimes because a sketch can be a prototype. A prototype is often defined as a representation of a design before the final design is produced, and sketches often accomplish that. And also, a prototype can be a sketch, meaning that it can be produced on pen and paper in a very rapid fashion, and low-fidelity prototypes are in fact just that. But the thinking that goes into sketching and prototyping is a bit different, and you can think of it as kind of a spectrum. Bill Buxton has talked about sketches as being evocative, where prototypes are didactic and try to explain. Sketches suggest possibilities and opportunities, where prototypes describe a particular idea that you're trying to get across. Sketches explore while prototypes refine those initial explorations. Sketches might help raise questions, whereas prototypes try to answer those questions. Sketches propose ideas where prototypes can be used to test those ideas in assessments. Sketches might provoke, whereas prototypes resolve. Sketches are tentative, prototypes are specific. Sketches are non-committal, where prototypes are about committing to a particular idea and seeing if it works. So you could see sketches and prototypes as playing different roles in the design process, and each of them being connected to different processes that unfold within the broader design process. So we have on the one hand the process of generation, creating alternatives and elaboration of ideas, and on the other we have convergence, which is the reduction of alternatives and selection of contenders that are worth investing further in. And we go through these stages of convergence and generation multiple times during the design process. And typically, sketching is going to be associated with those generation phases where we're trying to expand the design space, and prototyping is going to be associated with those phases of convergence where we're trying to narrow down the design space and make decisions about which direction to go. So in the generation phase, you're going to be focused on sketching. You're going to be focused on quantity over quality, producing lots of different ideas. And you're going to be focusing on building the set of design ideas and not necessarily critiquing them or selecting which ones are viable, which ones make the most sense. You're just going to be trying to create a lot of different ideas so you have a lot to choose from. And you're going to apply lateral thinking techniques, which we'll talk a little bit more about in a minute, to help get you to think more broadly and to get out of your own way to generate lots of different ideas, especially when you get stuck in particular ways of thinking. In the phases of convergence, you're going to be focused differently. You're going to be thinking about how to synthesize those different ideas into something that's coherent. You're going to be thinking about applying criteria that you've established through your understanding of user needs and your requirements to decide which of those design ideas that you've sketched are going to be the ones that actually satisfy the design goals going forward. You're going to be focused more on critiquing, finding out what are the flaws and what are the strengths of each idea so that you can pick the ones that are going to work the best going forward. You're going to be focused on eliminating certain ideas and promoting other ideas to take forward in the design process. One thing to keep in mind when you're sketching is that you will get stuck. Everybody does. You get to a point where you've run out of ideas. You've put all your best ideas down there and you think you've got nothing left. Well, it's important to push through that point, and there are techniques that you can use to help you get through that. So techniques that you can apply include things like brainstorming, which is typically a collaborative process with multiple people, and there are specific techniques that can be used to generate the best ideas from a group and capture them. There are other techniques that you can apply on your own. For example, matrix techniques, where you lay out different design ideas and different criteria for how to develop them and force yourself to fill in that whole table with different design ideas and kind of make yourself explore a whole space. And one particular form of this is called morphological analysis, which I'm not going to talk about in any more detail right now. Another idea that I really like is a technique called the worst idea. So when you're stuck and you're trying to think of good ideas that will solve your design problem, switch to think about the worst idea you possibly can for solving the problem. So here's an example of really bad ideas for improving the photo sharing website Flickr. So maybe you could take people's photos and just smear them all together. Maybe you could take inspiration from failed products like New Coke and the Edsel. Maybe you could make the navigation really, really bad so that people could not figure out how to get anywhere. Or maybe you could just make it look totally random. And sometimes by doing this, you can use them for inspiration. You can think about what it is that makes those ideas so bad and focus on how you can fix them. And every once in a while, something comes out of this that will actually point you in a direction that you wouldn't have gone otherwise. So go and sketch. The most important thing to get out of this is that sketching is an important part of the process. And when you're sketching, you need to think about doing quick sketches that are imperfect rather than trying to perfect each idea. You're trying to generate quantity over quality because what you're focusing on is generating ideas rather than selecting ideas and converging to the one great idea. And you can use lateral thinking techniques when you get stuck as a way to break through sketcher's block and come up with more ideas than you might if you just followed your initial instincts in the first place. When you're studying UX or when you work in the field, you start to hear a lot of different terms and terminology for different things that we do in the field or different ways of describing some of the things that we're talking about in these courses. And it can be a little bit confusing. A lot of those terms that you might hear, whether it's human-computer interaction or interaction design or user experience research or usability engineering or human factors, a lot of those come from different parts of the history of UX and how it's evolved over time. So I thought it would be useful in this lecture to just take you through the history of UX, one version. I'll say at the outset, this is a very brief, very incomplete history, very much from my perspective. If you asked 10 different people in the UX field about the history of UX, you'd probably get 15 different stories. So there's a lot of different ways that this story can be told. But hopefully this will be useful for at least putting into perspective how we got where we are today. And where I want to start this story is back in the early 80s, which is when the field of human-computer interaction was first getting started. And the thing to realize about this period in time is that this was the beginning of the personal computing era, the PC era, where we were starting to see for the first time non-programmers using computers. So before this, you had things like the graphical user interface, point and click interfaces, devices, or computers like the Apple Macintosh, pretty much the only people that were using computers were highly trained professionals that had gone through a lot of education to be able to write programs for the computers. They knew a lot about how computers work. They memorized very arcane commands that they would type into these devices to get them to do what they wanted. And now all of a sudden, in the late 70s and the early 80s, this world of computing was opening up to a vast array of other types of users. These might be secretaries who were doing a lot of word processing, or people who were entering information into inventory databases and various other types of users. And the question was, how can we design, how can programmers or people who are computer experts design software for these non-programmers to use? And a lot of people in the fields of computer science and psychology started thinking really hard about this question, thinking about whether there were principled ways to design these types of systems. And a landmark in this story was the publication in 1983 of a book called The Psychology of Human-Computer Interaction. It was written by Stu Card, Tom Moran, and Alan Newell. And this had a big impact on bringing that field of HCI together in those early days, because it was the first attempt to really say that we can scientifically and rigorously use what we know about humans, about human psychology, about human perception, about human cognition, and how people work to design systems that will work for them. Around the same time, a community of people was coming together and starting to identify as a community that was interested in studying these types of problems. So in 1982, we had the first CHI conference, and CHI is the premier conference in the field of human-computer interaction. The long name is the Association for Computing Machinery's Conference on Human Factors in Computing, but everybody in the field calls it CHI. The first conference happened in 1982, and it's still going strong today. So here's a picture from 2016 in San Jose, California. There were 4,000 people in attendance there, and as you can see from this picture I took of a conference session I was trying to get into, it's just overflowing and filled to capacity. So the Card, Moran, and Newell book and the beginning of the CHI conference was the beginning of the academic community that was coming together to study these issues of human-computer interaction. That's the term that we use for the academic field that studies the way that people interact with computing technology and how we can design better systems. But at the same time, a professional practice started to emerge in the 1980s. However, it was very closely tied to that academic community in the early days, because the only way that you could really learn about what was going on in the field of HCI was to go to the CHI conferences, or maybe you could take one of a handful of HCI graduate courses that were sprinkled around in universities in the US and elsewhere, mostly in computer science and psychology departments. But there wasn't, a degree that you could get, or there wasn't a course of study that you could pursue that would just be about HCI. Towards the end of the 1980s, we started to see a handful of books come out that were aimed at a wider audience, that were aimed at professional practitioners and other people that were interested in some of these issues around human-computer interaction. So in 1986, we had User-Centered System Design by Don Norman and Norm Draper, which was the first book to really articulate this idea of user-centered design that's still very much at the center of UX practice today. In 1987, Ben Schneiderman came out with Designing the User Interface, which was the first textbook of human-computer interaction that was meant to be used in university courses to teach this stuff. And in 1988, Don Norman published The Psychology of Everyday Things, later republished under the name The Design of Everyday Things, which was a very influential book that reached beyond the community of HCI, that introduced a lot of these ideas to a wider public and became very important in promoting this field outside of its smaller origins. But in terms of the way that human-computer interaction was incorporated into system design during this period of time, is that usability was primarily seen as the main factor of concern, and it was seen as a software engineering issue. And so you had usability testing starting to be performed as part of software development, but it was often performed at the end of the development to validate the product and say, yes, this is ready for release. But it would be done very late and much too late often to really influence the design of the product in the first place. And user interface design, or UI design, was often used as a way to put a pretty face on software whose functionality was pretty much already determined. So a UI designer would come in at the end and sort of decide where the buttons should go and which buttons there should be and what the labels on those buttons should be and maybe what some of the graphics should be, but they wouldn't have very much influence on the functionality of the software, because that would have already been determined by the software engineers who were working earlier in the process. So flash forward to the 1990s, and a big sea change was starting to happen that was going to influence the way that this field evolved going forward. And a couple of key time points in this big change were, first of all, in 1988, the World Wide Web was invented by Tim Berners-Lee, essentially provided a specification to allow pages to be linked to each other to make it very easy to share information on the internet. It wasn't until 1991 that what we now consider to be the first web page was actually published by Tim Berners-Lee. And one thing that's interesting, when you look at this original web page, the statement in here, everything there is online about the World Wide Web is linked directly or indirectly to this document. So that was a very different era than we have now, with billions and billions of web pages and really no way to make sense of everything that's out there. Another milestone in this progression was the release in 1993 of the Mosaic web browser. So while the World Wide Web existed before this and there were web pages out there, there was not really a convenient, user-friendly way for people to access it. The Mosaic browser came along and made it much easier for people to access the web, to follow links and go to different places, and also to be able to see images for the first time in a way that was convenient and integrated with the page layout. A huge milestone occurred in 1995 when the National Science Foundation, who was in charge of administering and governing the internet, changed a rule to allow internet commerce to go forward. And very shortly after that, Amazon.com released one of the first major online stores that had a big impact. And you can see on this slide the original version of Amazon. It looks pretty different now. But that opened the floodgates to lots of companies and lots of different other types of organizations suddenly becoming very interested in the potential of the internet. And so you saw a lot of investment, you saw a lot of activity, and ultimately that led a few years later to what we refer to now as the dot-com bubble, which was a huge explosion of e-commerce websites and different types of businesses getting onto the internet and trying to figure out how to make that something that could be profitable and could provide different types of services to people. And so suddenly, in the late 90s and early 2000s, a lot more people were dealing with this stuff, were interacting with computers to do a lot more different types of things. So a lot more companies were getting involved, both new companies and existing companies. A lot more users who hadn't really had a reason to interact with computers before were using computers to do a lot more stuff. So here's a graph that really illustrates how dramatic the rise of the internet was during this period. So if you look at 1995, the year that internet commerce was first allowed, when Amazon was founded, you can see that the bar is so small on this graph that you can barely even see it. You go forward a little bit even to about 2000, and you're already looking at hundreds of millions of users, which pales in comparison to the number of users today, somewhere in the neighborhood of 3.5 billion, or roughly half the world's population. And you can see why companies and other organizations who were interested in reaching users and consumers would have started really paying attention to this phenomenon and starting to figure out how to get involved in it. And so in that early era of the dot-com bubble, you saw a huge growth in the number of jobs in the technology sector, specifically around the creation and the evolution of these websites. And so you saw lots of software engineering jobs, but you also saw thousands of new web designers that were getting into the field and trying to figure out what's the best way to design websites to reach consumers and to meet these business needs. And so it became clear during this time as well that user interface design and usability engineering, the way that it had been done as part of the software engineering process, wasn't really enough to capture some of the dynamics of what was happening and what people were trying to do with the internet. So a term that became popular that was discovered by the web design community around this time was this concept of interaction design. Well, interaction design was a term that was actually coined in the mid-1980s by these two gentlemen, Bill Verplank and Bill Moggridge, both of whom were industrial designers by training. And they were trying to describe how industrial designers who had traditionally worked with physical products that might be things like furniture or appliances were starting to have to deal with this notion of interactivity as software was starting to move into those products. Well, people in the web design field picked up this term and started to use it to describe what they were doing because it gave them a way to capture the shift beyond user interface design, beyond this just putting the pretty face on the product at the end of it, beyond usability engineering, beyond this idea of just testing the product at the end, but actually getting involved earlier in the process in deciding what the interaction should be and how these things should go together. Also beyond human-computer interaction as a way of differentiating the professional practice from the academic research field that was studying the way that humans and computers interacted. And also beyond some of the other fields that were feeding into this phenomenon of web design. So a lot of people were coming to this not necessarily from the background of human-computer interaction, but from graphic and industrial design and other places. And they were looking for a way to describe what they were doing that made sense to them as well. And also beyond software engineering, to differentiate the discipline of interaction design from the discipline of software engineering, or to distinguish between deciding what the product should be and how it should work from the process of building it and validating that it does work as it should. A second shift was just on the horizon, though. So you can see that in 1985, right around the beginning of the personal computing era, a very small percentage of households had a computer in the house, so 13%. By 2000, that number was up to 44%, but it's still less than half of the households had access to a computer in the home. Go forward to 2014, just a couple of years ago, and pretty close to all of the households in the developed world have access to a computer. So what we can see from this is that computing technology and interacting with computers is moving out, very much out of the workplace and into people's everyday lives and starting to be used for the things that people do: shopping, education, entertainment, and all kinds of things that are not workplace related. So that was one shift that was happening. And another dramatic example of the diffusion of computing technology into people's everyday lives can be seen through this graph of the adoption of mobile phones, which really grew quite dramatically throughout the aughts, to the point where you can see in 2014 that there were 120 mobile phones per 100 inhabitants, meaning that people on average own more than one mobile phone. And you compare that to 1997, where it was barely a fifth of the population had access to these types of technologies. So that was another really dramatic shift. And that caused a shift in the way that companies started to think about the way that they could use technology and the way that technology facilitated their interaction with their users and with their consumers. So you saw another shift from websites to these new forms of interacting with consumers and with users in the forms of apps and services, moving on towards new types of devices and all kinds of different ways that this was changing. And so what characterizes this latest shift in the way people interact with technology is that we really see computing as a way of life, not a special activity that people do sometimes. In some sense, we're always connected, or we're almost always connected, and those connections are part of every aspect of our lives, not just sort of isolated to things that we do at work or things that we do at school. And from a business perspective, businesses started to see computing as part of an ongoing relationship with customers. So not just a matter of publishing a site or shipping a product, but a way of maintaining an ongoing relationship through perhaps multiple products and multiple sites and multiple apps and multiple services that were being provided. And so we saw a merging of usability and interaction design with other concerns that had previously been separate. So with things like marketing and branding, with market research. So now insights from market research were being blended with insights from usability research and user experience research. A merging of these user experience or user-centered perspectives with product strategy. So, not just being brought in at the end to provide a pretty face or to provide usability testing to validate something, but actually being brought in at the beginning to figure out what should we be building, what should we be making, and how should we be reaching people. And also increasingly a merger of usability and interaction design with physical design as we start to move off of the web and into mobile platforms and wearables and the Internet of Things and all kinds of other forms of technology. And fundamentally, what we've seen throughout this phase of the history of user experience is a recognition of user experience as a central concern for products and brands and enterprises. So it's no longer a peripheral concern or an afterthought, but often a central concern that is essential to the success of these enterprises. And so user experience today, as I said, is now seen by many firms as strategically important. User experience shares a common set of concerns and basic approaches, but we're also seeing that there's an increasing degree of specialization within the field. And this is a topic that we could go into great depth on, but I'm just going to kind of give a sense of it. And so one of the splits that we see, or one of the ways that people often specialize, is to specialize either in UX research or UX design. And there's plenty of people that do a fair amount of both. But even within those specializations, we're starting to see subspecialization. So within UX research, you have people that specialize in qualitative UX research that primarily do interviews and ethnographic observations, and people that specialize in quantitative UX research that are maybe more concerned with analyzing large data sets of analytics and clickstream data. And on the design side, you see people specializing in different aspects of the design chain. So specializing in visual design, or kind of the more graphical aspects of the presentation, versus interaction design, figuring out how all of the different pieces fit together, or information architecture, what's the best way to present information, large volumes of information to users. And then sitting on top of this, you have sort of the more overarching specializations of things like project management, user experience, strategy, and so forth. So when we try to put it all together, it can look pretty messy. So here's an example of a diagram that tries to put together all of the different concerns that feed into this notion of user experience design and user experience research. And you can see that this diagram tries to capture the relationship between user experience design and interaction design and human-computer interaction in marketing, in information architecture. And you could draw this diagram 1,000 different ways, and it probably wouldn't get very much clearer than this. But the really important thing is that in a nutshell, the history of UX, however you look at it, really is the history of user-centered design, of putting the user at the center of the design process and making decisions about how to design products with the user in mind. And over time, that user-centered focus has become more and more central to the way a lot of products are being designed, which is great. The terminology changes, but the focus remains on the user. And it also evolves to incorporate new things as we move along. So incorporating physical design and marketing and big data analysis and all kinds of other things that have become sort of brought into the UX fold. Specialization is common, as I mentioned, especially now with a large and growing industry, but it's important to be knowledgeable about the big picture, to understand all of these different aspects of UX, even if you're only going to spend most of your time doing one of them, because you need to know how they all fit together. And another important thing to get out of this is that user experience is increasingly important to business and really to everything that we do. And a final important point is the world needs more UX experts. And so I hope that you will be one of them. When designing user experiences, it's important to understand how we humans take in information about the world around us. And of course, the way we do that is through our senses, through sight, hearing, touch, smell, taste, and a few others that we don't talk about nearly as often. In this lecture, we will focus on visual perception because most information that we receive in general is conveyed visually, and that's especially true when we're talking about graphical user interfaces. So we'll try to understand how visual perception works and how we can use that information to design interfaces that work well for delivering information to users. So here you see a graphic representing the human field of vision. And what I want you to notice is, here over on the side, we have peripheral vision. And this is the part of our field of vision where we don't pick up very much detailed information. In fact, we can only see essentially contrast, light and dark, black and white in our peripheral vision. We can't do things like read text or recognize faces if things are only appearing in our peripheral vision. right here in the center, in this area that's labeled central vision, the 5 degrees of central vision, is essentially the only part of our field of view where we can pick up that kind of detailed information, where we can read text, we can recognize faces, we can recognize images, and things like that. And so how do we read or pick up information from more complex visual stimuli, such as a form on a web page or something that we might see on a graphical user interface? Well, we do it by jumping our eye around to pick up different parts of the image that we're looking at. Because we can only really get detailed information from that central part of the field of view, we have to jump around to different parts in order to pick up information from each of those different parts. So what we see here is an example of a person looking at a web form. And what you see, starting with the green right here, and jumping here, 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 and so forth, and ending right here, is the sequence of eye fixations, or saccades as they're called, that the user performed when picking up information from this web form. And so in order to see all the different parts of this form, they had to jump around through multiple eye fixations to pick up the information. Now, what's interesting about this is you'll notice that not everything on this particular form was actually ever even looked at by the user in this particular instance. So for example, this cancel button or this cancel link right here was never even looked at, nor were any of these options up here. Now, probably it's because they were not relevant to this task, but when designing a visual presentation, you need to recognize that just because you put something on the page or on the screen or on the image doesn't mean that your users are necessarily going to look at it. And so this process of sequential eye fixations, or saccades, is also how we read text. Because we've learned how text is supposed to flow, so in Western languages like English, they tend to flow from left to right, as shown in this screen, we know to fixate our eyes in a particular sequence. So here we see, that the reader has fixated here, and then here, and then here, and so forth, and moved throughout the page. So saccades, or sequential eye fixations, are how we pick up information from a lot of static images, like pages of text or web pages that we perceive online. A series of research studies have shown how people tend to process web pages online. And so this is interesting to note that people don't necessarily read all parts of web pages equally. And what's been shown through a series of studies, mostly performed by Jakob Nielsen, is that people tend to follow an F-shaped reading pattern when looking at different types of web pages. So if we start over here on the right, you can see a Google search page, and you can see that there's kind of an F pattern that people follow. And what this is showing, by the way, is a heat map of many, many people looking at a web page. They're using eye tracking technology to pick up where people are looking, and then the red regions are places where a group of users, through multiple studies, spent the most time looking at the page. Yellow is a little bit less. Blue is even less than that. And the areas that are gray are places where essentially nobody looked at all. And so what you can see is that a lot of people look in this region up here, top left, because this is a place where the first search result shows up, and most people expect there to be high-value information there. A relatively smaller number of people read the entire first line, but a lot of people go down to the second line, the third line, and by the time you get to the fourth search result, you're seeing a significant drop-off in the number of people that even look at that page. And so you can see this as kind of an F-shaped pattern where most people will follow the first line and the second line and maybe scan a little bit down the left-hand side of the page looking for potentially valuable information. But these areas over here are not going to get very much attention at all. And we see a similar pattern on other types of pages. So these are information pages, not search result pages, but we still see that people spend time at the top reading across, reading down, looking for information, and then maybe selectively picking one or two places to actually read farther into the page. And we can see a similar kind of pattern over here. So given what we just talked about with regards to the human visual system and how it works in terms of eye fixations and the fact that people don't necessarily see everything that's put in front of them, we can think about some principles for design and evaluation that can help guide us towards delivering better user experiences. So first, and probably the most obvious, is that we need to make important information and actions visible. So we didn't even need this whole lecture to know that if something is not visible on the screen, people will not be able to perceive it. But it's important to remember that that's the case, and I'll show an example in a minute. The second principle is that we can leverage the read, the natural order that people use to progress through different parts of visual presentation, such as the F-shaped pattern that people use for reading web pages. And third, when evaluating through user testing and things like that, ask yourself, did users actually see the information that I was trying to present to them, or did they miss it entirely? So first, making important actions and information visible. So let's imagine maybe I'm interested in pursuing a master's degree at the University of Michigan. Well, I might come here to the School of Information webpage and start looking for information about the master's program that would be related to user experience research and design. Well, the first thing that we notice looking at this page is there isn't any information or specific action that leads me directly towards the pursuit of that task. So already we can see that it's a problem when the things that users want to do are not immediately visible or perceivable on the screen that's presented to them. Well, if I look a little bit more carefully, I can start to reason about where I might like to go. I might look in programs. I might look for the master's program up here, or I might notice that there's resources for prospective students and look there. So here, I'm looking for information, again, about the master's degree. And if I look at all of the options that are clearly available to me, I can see that there is admissions information. However, it's not clear to me which of these links is going to tell me more about the program that I want to apply to. It turns out that that information is visible just below the bottom of the screen, or as UX designers often refer to it, below the fold. And I need to scroll down in order to get to it. If I scroll down, I can see why pursue an MSI, and that might give me more information about what I would get if I did that. But what I want to point out is that information that is not immediately visible and perceivable by users is less likely to be noticed, and if extra effort is required to find it, the number of users that will find it and take action on it is going to be reduced significantly. So our next principle is leverage the read, or the natural progression that people follow when taking in information from a static page, in particular a web page. And for this, we can look at the edX homepage. This is the page that I see when I go to edX. And you can see that they're taking advantage of the natural reading pattern that people tend to pursue when they visit a web page. And as you remember from before, people tend to pursue an F-shaped pattern where they start at the upper left corner and read a bit over here to the right. They maybe go down the page, look for other promising areas, and read to the right from there. And you can see that the information that edX has laid out is the information that they believe is going to be of interest to the largest number of users that come to the site. So when you start here in the upper left, you have an eye-catching graphic with a very clear call to action, which is going to deliver value for most of the people visiting the site. And over here to the right, you have another call to action that's also going to deliver value for perhaps a smaller number, but still a large number of users. And then down here, you see a number of pre-selected courses that are going to appeal to certain users that maybe didn't find what they want at the top of the page. And finally, something to keep in mind when you're testing user interfaces and potentially seeing issues that people have is ask yourself, did people ever actually see the information that you were trying to present to them? So for example, when we looked at this page on the SI website, we might ask ourselves, if people were unable to find that particular link, which was the one we determined would be the most valuable for the task we were trying to accomplish? Is it because they saw it and they didn't know what it meant? Or is it because they followed the F-shaped viewing pattern and they never actually saw it because they gave up before they got there? So we can take advantage of this knowledge of how people read the page when conducting usability evaluations as well. So that's a basic introduction to the human visual system and how we perceive information. And in the next few lectures, we're going to get into more detail about how the visual system works and how we can use that to design better interfaces and better experiences. In this video, we'll be talking about how we process visual information, or how do we go from having a bunch of photons hit the retina in the back of our eye to actually looking at an image like this and interpreting it as a bowl of fruit that has oranges, apples, plums, and bananas. Or perhaps more relevant, how do we look at an image like this and interpret it as a web page that's presenting a bunch of boots that are available for sale at specific prices with different brands and different model names and so on and so forth? Well, psychologists who study human vision describe it as taking place across 3 stages. So in the first stage, our eye breaks down the visual field into a set of features, which are things like colors and different shades and different line angles and slopes and so forth. And then we compose those features into patterns that are things like shapes or groups of shapes that are connected in different ways. And finally, we interpret those patterns as objects that we recognized, like dogs or ice cream cones. So starting with the feature detection, we know that there are a set of primitive features that our eyes detect very, very rapidly when we look at some visual stimuli. For example, we see things like color instantly. We break the visual field up into regions of different colors and also different values or different shades, so ranging from light to dark. We also are very attuned to noticing different edges and lines and how those lines are related to each other. So we immediately break the visual field up into intersections of lines and the angles that they make. We also notice different lines, the slopes or orientations of those lines, the lengths of those lines, and things like that. We also notice regions that have different textures. And we're also very attuned to noticing motion. So anything that is moving in our visual field, we pick that up and we notice it very, very rapidly. So let's look at an example of how this works and how some of these different visual features work in terms of processing information. So we're going to do a little experiment here. I want you to find the orange triangle in the next screen that I show. You ready? Go. That was pretty easy, wasn't it? The orange triangle differs from all of the other stimuli in the visual field in only one dimension, and it's very easy to tell the difference between the blue triangles and the orange triangle. Let's try it again. This time I want you to find the orange square in the next screen that I show. Ready? Go. Okay, that was probably not quite as fast, but still pretty easy. And the reason is because it differs in shape from the other stimuli, but not in color or in any other features. And in particular, in terms of the visual features that we just talked about, the slope and the angles of the lines are different, and our eye is immediately drawn to that difference given the other shapes that are available in the visual field. Okay, now we're going to try a third experiment, and let's see how this one goes. I want you to find the pink triangle that is pointing towards your right. Ready? Go. Okay, that one was probably a little bit tougher. Why was it tougher? Well, because the target that you were looking for varies in color and orientation from the various distractors that are available. And there are some triangles that are pointing in the same way but that are different colors, and there are some triangles that are different colors but are pointing in different directions. So what we don't have access to here is we don't have the pop-out that occurs when there's a simple differentiation in the visual feature space of an object compared to the rest of the visual field. And we have to resort to what's called visual search, where essentially we have to scan all of the objects in the field in order to detect the one that we're looking for. Now, if we add some other features like motion, we start to see the pop-out come back, and it's very easy to detect something like the triangle when it's moving. So visual feature detection happens very fast and very primitively. It's believed to be hardwired into the apparatus of our eye and our neural processing system that interprets visual images. So it's very fast, and it allows certain features of the visual space to pop out. That is, to draw our attention immediately without any conscious effort. And this baseline feature detection is what supports subsequent stages like the recognition of patterns and the recognition of objects. So the first thing that happens when we look at this bowl of fruit is we break it up into its basic features. So we see the regions of different colors, we see different textures, like the difference between the orange texture and the plum texture, and we see the edges between different objects, like the edge between these two apples that's shown here. So the next thing that happens is we take those visual features and the decomposition of the space into those features, and our eye automatically seeks patterns to make sense of the arrangement of those features. And a set of psychologists in the early 20th century, known as the Gestalt School of Psychologists, studied the way that this pattern recognition works. And they identified a set of principles that define the way that our eye breaks up the visual field. So for example, we use proximity to determine what parts of the visual field ought to be associated with each other and which are likely to be part of a different pattern. So here up in the upper left, we see this example of the two rectangles that are close together are much more likely to be associated as being part of the same group or part of the same pattern as this one over here that's by itself. We use closure and continuation to complete objects that might be occluded by other objects. So when we look at this circle right here, we don't notice the dashed lines as being separate objects. We notice them as being part of a circle, and we notice that the circle, we see it as a circle even though there's this part missing right here because our eye automatically closes the circle for us. We use symmetry to organize the visual field into patterns. So when we look at this image of what looks like a sun here, we see it as a single object, a sun with rays coming out of it, largely because of the symmetry of the object. By comparison, when we look at this object right here, we're much more likely to see that as a set of different objects or different patterns that are overlaid on top of each other, in large part because of the lack of symmetry. It's harder to see this as a single object or a single pattern, and easier to see it as a set of intersecting patterns. We use similarity to group things into patterns and identify patterns that go together. So we're much more likely to see these three circles as being related to each other and part of the same pattern, and perhaps these trapezoids as being part of the same pattern, and see this heart right here as being something that is separate because it doesn't share similarity with anything else that's in the field. And when we see things that are grouped into a common area, that share a common boundary, we're more likely to see those as part of the same pattern as opposed to something else that might be seen as part of a different pattern. And we also use movement to group things and group aspects of the visual field into patterns. So for example, if we look at these four circles or ovals down here, we immediately see them as a single pattern of four things. But as soon as we start to see some of them move separately, we start to see them as two different patterns and likely two different groupings or two different sets of objects. So we use these Gestalt principles to break up the visual features that we detect in the first stage into different patterns that we can then use to recognize objects. So we use things like proximity to show that these two regions here, this lighter region and this dark region, are likely to go together into the same object because they're close together. We use continuation right here to recognize that this green shape, which will turn out to be an apple, continues even though it's occluded partially by the apple that's in front of it. We use symmetry to recognize that the different textures and gradations of this orange go together and are part of the same object. We use containment to detect that all of these fruit are contained in the same bowl and are grouped together. And we use similarity to identify different regions as being of the same type and of the same pattern together. And the third stage builds on top of this pattern recognition and uses our prior learning to be able to identify the particular objects that we have now broken the visual field into. And so we can recognize things like oranges, apples, bananas, and plums in the bowl that contains them. So how can we use these principles of the visual system and visual perception when we're designing interfaces that people will be using? Well, here are a couple things that we can draw from what we've just been talking about. One is that we can use pop-out, or these primitive features like color, shade, line, orientation, angle, and motion to attract attention to things that we want to make sure that users notice. We also can use Gestalt principles to associate like items. And similarly, we can use Gestalt principles to organize the page to make it easier for people to skip around and find only the information that they're interested in and ignore the things that they're not interested in. And now we'll look at a couple of examples of how these principles play out in different user interface designs. So if we look here at the Amazon homepage, you can see several examples of using pop-out or these primitive visual features like color and line and contrast to draw the user's attention to different parts of the page. So for example, if we look here at these icons indicating electronics, toys, and these different categories, they're using bright colors and strong contrast to draw the user's attention to those areas. You'll also notice that this area up here is using motion to attract the user's attention. By cycling through these different advertisements, it draws the user's eye to that area and asks them to pay attention to it. And finally, we can see pop-out being used here with this button, which is a call to action to ask the user to sign in, where it's using color and contrast to draw the user's eye to the button and asking them to perform this action. Notably, these areas up here, the navigation areas, are explicitly not using strong visual differentiation or pop-out to draw the user's attention. Skilled users or knowledgeable users will look there to find the things that they need, but they don't need their attention drawn to it. So pop-out is being used to draw attention to the areas that the user might not notice or might not be looking for on their own. What happens when we use pop-out and these primitive visual features ineffectively? Look at this page. There's a lot going on here, and it's very hard for the eye to pick a place to look on this page because everything is asking for attention. There's a lot of bright colors, there's a lot of contrast, and there's a lot of motion going on. There's all these animals crawling around, there's fingers pointing, there's stuff flashing, and it's very difficult because all of these different visual features like motion and color and line are being used at the same time, and they're all demanding the user's attention. So this is obviously an extreme case, but if we're not careful and we're not selective about how we use these visual features, we can make it very difficult for users to be able to interact with something that we design. Turning our attention to Gestalt principles, we can look at this page from Zappos as an example of an effective use of Gestalt principles to help organize the visual field and make it easier for users to navigate the page. So what you see here is you see the use of similarity in the presentation of the different items, in this case boots, that are being offered for sale. The images are the same size. In fact, all of the boots are photographed in the same orientation to make it very easy to compare across them. And you can very rapidly tell that for each of these different entries, you're going to get the same information because the structure is similar across each of them. So you can see the image of the product, then you can see the brand, you can see the model, you can see the price, and you can see the ratings, and you're going to see that repeated across each of these. At the same time, this structure, which is using similarity and also proximity, by the way, allows the user to skip around and ignore things that they're not necessarily interested in. So if I know that I am looking for a particular boot that I want to purchase, I can focus my attention on this part of the page because I can see that it is very clearly distinguished from this part over here, which is essentially going to give me filtering and search options, or these parts up here that are going to give me navigation options for the rest of the page. And so by clearly differentiating those and breaking the similarity between these different parts of the page, it enhances the skippability of the page, meaning that I can skip around as the user to the parts that I'm interested in, and I can ignore the parts that I'm not interested in for the task that I'm trying to accomplish. So these principles can be used to design more effective visual presentations when presenting options and information to users. So if we use pop-out or primitive features to attract attention and avoid using pop-out or differences in primitive features when we don't want to attract attention to particular parts of a visual presentation, we can make it easier for users to direct their attention. And if we use Gestalt principles to associate like items and disassociate items that are different to allow users to skip items that they don't find, that they're not as likely to find interesting, or that are not relevant to their current task. So what happens to information after we perceive it? So if I show you a bowl of fruit and then I take it away and I ask you how many apples were in that bowl, would you be able to answer it? Would you be able to tell me how many plums or how many oranges? The only way you would be able to know that is if you had access to it, if it was stored somehow in your memory. So in this video, we're going to talk about how information goes from being perceived and taken in particular by our visual system, and how that information does or does not make it into our memory as something that we can then access later. Here's a very simple depiction of how this whole process works. We have our senses, we have our eyes, our ears, our nose, our mouth, our sense of touch, and information about the outside world is available to us through our senses. Some of the information that's available is perceived and made available for thinking and for commitment to memory. And the process of remembering actually takes place in two stages. We have short-term memory, where we store information for a short period of time on the order of seconds, and we have long-term memory, where we store information for, as the name implies, much longer term, for durations of minutes to years to decades. And what we know is that for information to be transferred from our senses to our consciousness through the process of perception, it requires attention. We have to be paying attention to that particular sense at that particular time. And we know that as a result of this, a very small amount of what is available to our senses is actually perceived or actually something that we become conscious of. Whatever is perceived is available for thought, but initially it's only available for a few seconds. And a lot of what is available and a lot of what is transferred through the process of perception into our short-term memory is actually lost. If it's not committed to long-term memory, it's lost and we don't have access to it later. And we know that a relatively small amount of information is learned or committed to long-term memory from short-term memory. So the vast majority of the information that's available to us through our senses is essentially lost, and a very small amount of that is transferred to long-term memory and available for us later. In this lecture, we'll be focusing mostly on short-term memory and how that works, and in future lectures, we'll focus on long-term memory as well. So I want to do an experiment with you now to give you an intuition about how short-term memory works. And what I want you to do is, for the next few seconds, I want you to pay close attention to the screen. How many apples did you see? So the answer was 3, and I'm guessing that most of you got that answer right. And we'll talk about why that task was not very difficult in just a minute. But before we do that, I want to do the second phase of the experiment. And I want you to pay attention to the screen again. How many chickens plus ducks did you see? I'm guessing that that was a much more difficult task. The answer was 6. But why was it a more difficult task? Well, you probably recognize that there was a difference in the number of objects that were shown. There were a much smaller number of fruit that were shown in the first example than there were animals in the second example. And what this illustrates is that short-term memory has limited capacity. In fact, research has shown that the number is somewhere in the single digits. The original research back in the 1950s came up with what has been referred to as the magic number of 7 plus or minus 2 items, meaning that most people can hold about 7 items, in this case fruit or animals, in their short-term memory, and depending on individual differences, that number can be a little bit higher, a little bit lower. Subsequent research has put that number a little bit lower, maybe it's more like 4 plus or minus 1, but the point is it's limited, and it's a fairly small number of things that you can hold in your short-term memory without committing them to long-term memory. And information that is not retained or learned or committed to long-term memory is lost. You don't have access to that information later. And this process of committing information to long-term memory is what we call learning. So in the first example with the fruit, there were only 6 items. And that 6 items falls within that magic number of 7 plus or minus 2. So for many people, it was probably possible for you, even though you didn't know what I was going to ask you, to just play back through the sequence of fruit that you had just seen and count the number of apples that were in that sequence. In the second example, I showed you 13 items. And so by the time we got to item number 13, the first 5 or 6 items had been lost to your short-term memory. So if you didn't have a rule or a heuristic for keeping track of how many cats you had seen, how many ducks you had seen, and so on and so forth, you wouldn't have access to the information about how many ducks and how many chickens you had seen because you wouldn't be able to play back all 13 of those items. So the key takeaway is that short-term memory is limited. Whether it's limited to 7 items or 4 items or 9 or 5, it doesn't really matter what the exact number is. But we can use this information about how short-term memory works to come up with some principles for how we might design interfaces that work better for people. So some of those principles might include keep lists of options short, because if users have to read through a long list of options, by the time they get to the end, they will have forgotten what was at the beginning of that list. Also, in cases where you're going to present users with lots of information and lots of options, you should consider giving them tools to reduce the number of options that they have to compare or they have to decide between at any particular time so that they can use their short-term memory effectively. And finally, don't expect users to remember stuff from one screen to the next. If the information is not visible and you don't have a strong reason to believe that they would have memorized it or committed it to long-term memory, they're not going to have access to that information when you ask them for it later. So one of our principles is keeping lists of options short wherever possible. And to illustrate that, let's look at this example. This is a website that sells music equipment, musical instruments, recording, and so on and so forth. And if I look at the list of options, and let's say I'm looking at recording equipment, I see a long list of options. Pro Tools, recorders, microphones, headphones, and so on and so forth. And if I don't know exactly what I'm looking for, and I don't know exactly what category it would be in, by the time I've read to the bottom of this list, especially if there's lots of unfamiliar terms, I've forgotten what's at the beginning, and I might have to go through this list multiple times to decide where it is that I need to go next. And if it was a shorter list, it would be a much easier task because I'd be able to keep all of those options in mind when choosing where to go next. Another principle that we discussed is when presenting users with lots of options, give users tools to reduce the number of options that they have to think about at any one time. And for an illustration of this, I'm looking at the Newegg website. Newegg sells computer equipment and hardware and things like that. And I'm looking at different graphics or video cards. This is something that I did recently with my kids when I was helping them build gaming PCs. So that's why I'm familiar with this. And there's a bewildering number of options, and I've just reduced this, in fact, to the set of graphics cards that are that are recommended for gaming, and it's pretty overwhelming. So what this website has done, and many other websites offer features like this as well, is it's given me the option to pick a subset of these items to compare against each other. So I might pick this one, and this one, and this one, and compare them, and now I only have 3 items that I need to compare with each other, and it's much easier when I'm looking at a particular feature. Let's say I'm looking at clock speed, or I'm looking at memory size, or I'm looking at price. I can compare those very easily because the number of options fits within my short-term memory, and I can reason about them without having to do something that's more difficult cognitively, like memorize the different details of each of these items. Because of the limits of short-term memory, we can't expect users to remember information from one screen to the next if that information isn't available when they need it. So as an example, here's a website that I often use for ordering pizza. And when I use this website on my mobile phone and I click checkout right here, it takes me to this screen where it asks me if I would like to add a tip. And I would like to add a tip for the driver who's going to deliver my pizza. And usually I like to do that as a percentage of the total amount that the bill is going to be. However, I can't see what the amount was, and if I didn't commit it to memory earlier, I'm not going to know how to calculate the tip on this screen. It would be much more effective if that information, the bill, was made available to me on the tip screen so that I would know how much to tip, or perhaps even suggestions about how much to tip would be helpful as well. So we've just talked about the limits of short-term memory, and from that derived a set of principles that we can use for designing more effective interfaces. So first, we need to keep lists of options short, especially when users may not know exactly what they're looking for. Where we do need to present lots of options to users, we need to give them tools for reducing the number of options, especially when comparing among those options. And finally, we can't expect users to remember stuff that they've seen on previous screens or in other interactions with systems that we're designing when they're engaging in subsequent interactions. If the information is important for a task that they're performing, we need to make sure that that information is available and visible at the time that they're performing the task. We can't count on them to remember it from having seen it before. In this lecture, we'll be talking about long-term memory, which is where we store any information that we access more than a few seconds after we're exposed to it. And as you'll recall, not every piece of information that we're exposed to makes it to our long-term memory. So there's a lot of information that's presented to our senses that we never perceive in the first place. And a subset of what we perceive makes it into short-term memory, where we can operate on it for a short period of time, maybe a few seconds. And a subset of that information that enters our short-term memory is actually committed to long-term memory. So long-term memory contains anything that we remember for more than a few seconds. And for information to become part of our long-term memory, it has to be copied from our short-term memory to our long-term memory. And that process of transfer from short-term to long-term memory is what we call learning. So how does the transfer to long-term memory happen? Well, it happens really in 2 primary ways. One is through association, where some piece of information that enters our consciousness is associated with things that we already know, and it makes it easy for it to kind of fit in with the things that we know. And the other way is through repetition. So when we're presented with information that we don't really have any associations for, really the only way that that will become committed to our long-term memory is by effortfully repeating it to ourselves until we can commit it to memory. So let's take an example of how associative memory works. So our memory is fundamentally associative. All the concepts that we have in our memory are associated with other concepts in kind of a network structure that links them together. And if you have a set of associated concepts that kind of all fit together, like the concepts that are shown here, we refer to that as a schema, which is really just a way of talking about a particular network of related concepts. And so these are concepts that are all related to the idea of a farm. So you have animals that are on the farm: horse, donkey, cow, things like tractors, fields, pastures, corn, and so on and so forth. And if we're presented with a new piece of information, let's say, for example, you're presented with information, which I realize may not be new for most of you, but that if you have an animal who has one parent who's a horse and one parent who's a donkey, that animal is called a mule. Well, that's a piece of information, if it were new, that would be fairly easy for somebody who had those other concepts to remember, because it fits right in. And so you have simple association between the concept of mule and the concept of horse and the concept of donkey. And so that's information that's going to be easier and more likely to be committed to long-term memory and be more likely to be remembered later. In contrast, if I presented you with an animal called a Pliskofwik blue, and it looked like this, you might not be very inclined to remember this because it wouldn't fit in with things that you currently know, and it wouldn't have any place to associate. Now, if we don't have a ready-made association for a new piece of information, we're not going to be able to fit it in very easily, and we're going to have to put in more effort to remember it. So we engage then in the process of memorization or elaborative rehearsal, which is basically where we repeat information to ourselves until we've committed it to memory. So this is what happens when we're presented with information like this. Call us at 1-895-555-9368. That's going to be very difficult to remember that sequence of numbers because it doesn't have patterns that are easily remembered, and it doesn't fit in with information that we already have. Or if you're assigned a user ID that's 76277, 303, which, by the way, is the way that a lot of user IDs were assigned to people in the early days of internet service providers before they let people choose their own IDs. And this is obviously going to be much harder for people to remember, much more likely that they'll have to write it down and keep that piece of paper handy whenever they're logging in, than if they get to pick their own name, which is meaningful and probably has associations with things that they already know. Memorization is also how we have to learn arbitrary or complex commands, such as the things that we need to learn when we interact with Unix or a system that requires textual commands. And it's also the technique that we have to use when presented with directions, for example, like go straight and take the second left, then turn right and left again, and after the bridge, turn left and it will be on your right. That's going to be very difficult to remember because it doesn't fit in and we don't have anything that we can associate it with. And the only way we're going to remember it is either to write it down or to commit it to memory and repeat it to ourselves. So given these two options for how to memorize or how to commit information to long-term memory, which do you think is going to be easier for a user and which is going to be more likely to be remembered? If you said associative, you're right. It's much easier for users to learn and remember things that fit into an associative schema that they already have than it is for them to put in the effort to memorize something that doesn't provide ready-made associations. And the likelihood of remembering something is based on three factors with regards to that information. So one is the strength of association. How closely associated is it with information that the user already has and is already remembered? But also the recency, how recently were they exposed to the information and how frequently have they had to recall that information? Another important thing to keep in mind about remembering information is that memories are often primed by stimuli that we receive from the outside world. So we might be triggered by a word or an image or a sound or a smell to recall information that's associated with that if we've seen that image or heard that word or heard that sound or smelled that before. So we can present information that will fit into user schema by using metaphors, leveraging standards and consistency, and also when we do present information that fits into user schemas, we avoid asking them to memorize stuff and make it more likely that they'll be able to remember it when they need that information later. And another principle that we can apply is that we should prefer recognition over recall whenever possible. So one technique that we can use for presenting information in a way that fits into a user's schema is to use metaphors. So one metaphor that many of us are familiar with is the idea of a shopping cart on an e-commerce site like Amazon. And this leverages the metaphor of a physical shopping cart that many people would have experienced in a grocery store, for example, where you can add things to the cart and even take them out before you reach the checkout counter, and you only have to pay for things when you actually get to the point of checkout. And so by leveraging the metaphor of a cart, Amazon and other retailers were able to take advantage of the metaphor to explain to users how to use the site in a way that would make sense to them. Another technique that we can use to help users make sense of complicated systems is to take advantage of consistency across different similar products and different parts of the same product, and to take advantage of standards, which are similarities across competing products that might be trying to accomplish the same thing. To look at examples of this, you can see that this image up here, which is from Google Docs, uses a certain menu structure, file, edit, insert, format, and so forth, which is replicated in another one of Google's products, which is Google Spreadsheets right here, or Google Sheets. And it uses the same menu structure. And what this means is that a user who has learned to use one of these systems, in picking up the other one, will immediately know where to find certain types of operations like cut, copy, and paste, or save, or rename, or those types of things. Moreover, even a completely different product, Microsoft Word Online, is going to use a very similar menu structure, similar placement of options like formatting, changing fonts, and things like that, to take advantage of the fact that users who've learned one system are going to be able to rapidly transfer that information to another system and not have to learn everything from scratch. So using consistency and standards helps users who have already used a similar system use the system that you're designing without having to retrain. Wherever possible, you want to avoid asking your users to memorize stuff. One place that this comes up is in asking people to choose passwords. Passwords are a fact of life. Many systems require them for very good reasons. They need to keep the data secure. They need to make sure that you are who you say you are. And over time, more sites require more complex passwords in order to maintain security. And so here's an example of the kind of security policy that you might see for passwords. Password has to have 8 characters in length and contain at least 3 of the 4 following items: uppercase, lowercase, numbers, and symbols. By adding these constraints, you're forcing people to choose potentially more complex passwords that might have fewer associations, making it more difficult for them to memorize the different passwords that they have, especially as different sites have different requirements. This could actually create a less secure situation because people have to write these passwords down. They might write them on Post-it notes that are kept next to their computer. They might write them in documents that are stored on their hard drive and things like that, and it creates a difficult situation. The point that I'm trying to make here is that by asking users to memorize stuff, it makes things more challenging for them and can cause them to use workarounds which actually might subvert some of the things that you're trying to accomplish. Another principle to keep in mind is that you want to prioritize recognition over recall. That is, people are going to have a much easier time recognizing an option if they've seen it before than recalling it from memory with no prompting. Most graphical user interfaces do this very well by presenting the menu options that are available, the objects that can be operated on in the form of icons and things like that. But there's still a few places where we're expected to recall things from our memory. One of them is passwords, which we just talked about. Another is when we're searching for things. We have to call those search terms up from our memory to find the things that we want. So a few years back, Google introduced the autocomplete feature for searching to facilitate this. So we have to start with a recalled search term, but as we type it, we can see other suggestions that come from other people's searches, which might help us fill that out so we can actually recognize the search term that we're interested in from the options once we've started from a base of what it is that we think we're looking for.
So using these principles will help us take advantage of our knowledge of long-term memory when designing systems that will work better for people. So learning will work better if the learner can fit new information into a schema that they already have, and we can help them do that by using metaphors, by leveraging standards and consistency, and through doing this, we can avoid asking users to memorize stuff, which will be difficult for them. By preferring recognition over recall, by presenting options to users that they will recognize rather than asking them to remember things from their own memory, we can also help people accomplish tasks and design systems that will work better for them. In 1986, Don Norman published a book called The Psychology of Everyday Things. It was later re-released under the title The Design of Everyday Things. But this book has had an enormous influence on the field of user experience, and many user experience professionals have read it and used the concepts in this book on a regular basis. One of the things that Norman covers in this book is a model of how people act when they're acting in the world to pursue goals that they have. And this model is called the 7 stages of action. It starts with the user or the person forming a goal, so forming a goal about something that they want to accomplish, and then proceeds to forming a specific intention to act towards pursuing that goal. Given that intention, the user or the individual then selects an action of the set of actions that are possible in the environment where they are currently located, and then proceeds to execute the action. In executing the action, the person changes the world or changes the environment in some way to hopefully move them closer to their goal. So the next step is actually to perceive the change that they've made in the world, or to perceive the world as it is now after their action, and interpret the state of the world to try to figure out, did they actually succeed in moving closer towards their goal, or did their action not get them closer to their goal? In either case, they would then update their goal, either moving on to the next step, the next goal that they want to accomplish, or forming a new goal that would help them do what they need to do. When Norman wrote about the 7 stages of action, he talked about acting in the world and making changes to the world and perceiving the state of the world. But of course, everything that he wrote about applies to interactions with systems that were designed by people. So for example, it applies just as well to interacting with, let's say, an espresso machine, where the goal is to get a cup of espresso, and the user has to form intentions and select actions that will result in producing a cup of espresso that they want to drink. It also applies to software systems, like this example of the Amazon web page, where the goal might be to find a book and purchase it, or something along those lines. So let's look at an example of how these 7 stages would work in a simple case. So let's say I have the goal that I want to get out of my office and go down the hall to get a cup of coffee. So my larger goal is to get a cup of coffee. But my immediate goal, of course, is to get out of my office even though the door is closed. So looking at the environment, I would form the intention of opening the door so that I could get out of my office and go on to the next step. Sizing up the different possibilities, my next step would be to select the action, which in this case would be to grab the door handle and turn it so that I can open it. And of course, then I would execute the action, opening the door handle and pulling the door to open it. I can now assess the state of the world after having pulled the door open, and I can see that the door is open, that the new state of the world is that I now have a path in front of me where I can exit the office, and I can evaluate the outcome to say I was successful in moving closer to my goal of getting down the hall and getting a cup of coffee. Now let's look at another example and think about how we would apply the 7 stages of action to interacting with a website. So my son's birthday is coming up, and I know he likes Harry Potter. So let's say my goal is to buy a book for him, the most recent Harry Potter book that's just come out. So my goal is to buy a book for him, but my more immediate goal, of course, is to find the book so that I can add it to my cart and do all the other stuff. So my intention then is to find the book, and I'm going to do that by searching. So I'm selecting the action of searching. There's other ways that I could potentially go about it, but I'm going to select that, and now I'm going to execute that action by typing Harry Potter into the search box. Okay, Okay, I'm going to look down here, and I recognize this book here, The Cursed Child, as the book that I'm looking for. So I can perceive the state of the world. I see the search results and interpret it to evaluate the outcome that I have moved closer to my goal. I've successfully completed a search. It's returned the book that I'm looking for, so I know I'm moving along in the right direction. So I can now form a new goal, which is to look at this book and put it into my shopping cart. And so again, I'll form the intention of getting more details and getting to a point where I can add this to my cart, selecting the action. In this case, I will select the action of clicking on the icon, and I will execute the action. And now I perceive the state of the world. I see that I've got a page that's giving me more details about this book, and it has the option to add this to my cart. So I can interpret that as bringing me closer to my goal, evaluating the outcome that I was successful, and I could go on from there, add it to my cart, and so on and so forth. So these 7 stages of action repeat each other in the course of pursuing a larger goal. All along the way, I'm updating my immediate goal of what it is that I want to do next, forming the intention to act, selecting and executing the actions, and then perceiving the results of my actions to determine whether or not I'm getting closer to my goal. So using these 7 stages of action, we can take users' interactions with a system that we design and break them down into smaller steps that make it easier to see where problems might be occurring. And by doing that, we can get better insight into what we need to do to fix those problems so they won't occur in the future. So Don Norman's 7 stages of action give us insight into some of the ways that systems can fail to support users' goals and users' actions in trying to accomplish those goals. So one thing we can notice is that these steps over here form a pathway that lead to execution of an action on the world or on the system. Starting with forming the intention to perform a certain action, selecting the action, and then executing that action on the system or the world. And over here on the other side, we have the pathway of evaluation, of looking at the state of the world after acting on it and evaluating whether the action was successful and whether the action has led the person closer to their goal. And so looking at these 2 sides of the model, execution and evaluation, it helps us to see some of the places where breakdowns can occur. And Don Norman refers to these as gulfs, and he talks about the gulf of execution as being the challenge that a user faces when trying to map their goals onto the possibilities that are in the world and selecting appropriate actions that will help them accomplish their goals. So an example of the gulf of execution might be illustrated here with these glass doors that imagine that those signs were not there. A person trying to get inside the building would look at these doors and have difficulty knowing what action they needed to take to get those doors open and get inside the building. And you can see that it was challenging and that many users faced this gulf because the people whose door this is had to put signs up explaining in quite some detail how to operate this door. So it says, push this glass door to enter after pressing the buzzer. Do not push the black bar. And you can see that many people weren't even sure which door to push because they had to put another sign that said, push the glass door on the right. So this is an example of a door that presented the gulf of execution to people that wanted to get in. And in order to bridge the gulf of execution, somebody had to put some signs on the door explaining how to use a door. A door probably should not have to have instructions in how to use it. So here's an example of a more elegant way to bridge the gulf of execution, which is to use features of the door itself to indicate what actions are possible. So by including a push bar like this one, it makes it very clear where you should push, what action you need to take, which is pushing rather than pulling, in order to operate this door. The other side, Norman calls the gulf of evaluation, and that's the gulf that users face when trying to interpret the state of the world to determine whether their actions were successful and whether they moved them closer to meeting their goals. So an example of this might be these two buttons that are used for activating the crosswalk signals that don't give any indication of when they've already been pushed, whether the system received their input, and whether there is in fact going to be some change in the walk signal at some point in the future. So you'll often see people standing at intersections like this, pushing the button over and over again in the hopes that at least one time the system will accept their input and change the signal. Slightly better version of this would be just to add a little light that changes color or turns on when somebody pushes the button so that the user knows that their input has been received and the system is going to take action on their behalf. So when designing systems, we want to bridge these gulfs, the gulf of execution and the gulf of evaluation. And how do we go about doing that? Well, if we understand users' goals, what it is that they're trying to accomplish with the system, and how they think about accomplishing them, we can make sure that the actions that they need to take and expect to be there will be visible and available. So we need to make sure that the likely actions, the things that people are likely to do, are visible when they're needed and that they make sense, that people are expecting them to be there, they understand what will happen when they execute those actions, and it's framed in language or using images that they will associate with their goals. We also need to make sure that the results of their actions are visible and that they make sense, that they can tell that the feedback that they're getting indicates to them that their actions were successful and that the actions are leading them towards the goals or away from their goals so that they can take a different course of action. So when we're designing systems, we need to keep the gulf of execution and the gulf of evaluation in mind so that we can make sure we're designing systems that bridge those gulfs and help users accomplish their goals. For users to be able to effectively make use of a system that you've designed, they need to be able to discover what the system can do and how to operate it or how to make it do whatever it can do. And this is how we bridge the gulfs of execution and evaluation that we talked about previously. And to be more specific, to bridge the gulf of execution, users need to be able to figure out what actions are possible. And to bridge the gulf of evaluation, users have to be able to discover whether the actions that they completed were successful. And we'll talk about a few things that we can do to help bridge those gulfs and support the discoverability of our system. So we'll talk in this lecture about affordances, signifiers, feedback, constraints, and conceptual models. An affordance is a feature of an object or an environment that indicates the possibility of action. So to take this doorknob, for example, because of the size and shape of the doorknob and its fit to the human hand, it provides the affordance of graspability. It looks like something that we can grab with our hand, and if our hands were much larger or much smaller, it wouldn't have the affordance of graspability because it wouldn't fit into our hands. And by providing that affordance, it suggests what we can do with it, and it suggests an action that we can take. To provide another example, look at these buttons. These buttons provide the affordance of pressability because they're about the right size for a human finger to press them. And as you can see here, the stop button is raised, suggesting that it could be potentially depressed. And we often see these affordances or suggestions of actions that can be taken used in purely graphical interfaces as well. So in this case, they're not truly affordances because they're not truly attributes of the object that suggest the actions that can be taken, but we use the visual cues that we associate with affordances to communicate the possibility of action. So in this example taken from a bank website, you can see that these 6 buttons across the navigation area, savings and checking, loans, and so forth, have a slightly raised effect to them, suggesting that they could be pressed in the way that a physical button could be pressed. And by doing so, it suggests where the user might be able to take actions of certain kinds using this system. So while affordances are aspects of physical objects or physical environments that suggest how a user might interact with them, they often don't go all the way towards telling what will happen when the user interacts with them, or in some cases, where specifically they need to interact in order to make an action take place with the system. So to augment what we can accomplish with affordances, we often use what are called signifiers, which are more explicit signs or messages that indicate to the user what will happen if they take a certain action. So to return to this example, the affordance of pressability is provided by the raised aspect of the stop button and also the size of the button and its fit with human hands and human fingers. However, the specifics of what will happen when that red button is pressed as opposed to what would happen when the green button is pressed is communicated through the words start and stop. And that would be, in this case, a signifier or a sign showing specifically what will happen when each of these different buttons is pressed. Signs are not always textual. They're not always written out in the way that it was in the previous example. So here's an example of a walking path through a field that shows where previous walkers have traveled and indicate to somebody coming into the field later what might be the best path to get through this field. In this case, the sign is the worn area through the path, and it's provided simply by the actions of previous travelers through this area. Affordances and signifiers often work together to communicate what actions are possible and what might happen when those actions are taken. So affordances, if done well, can communicate very intuitively where the action needs to occur with a system or on an interface. But signifiers are often necessary, especially when many actions are possible and perhaps many actions share the same affordances. So to use this example again of the bank website, we can see that there are many different actions that are available to go to different parts of the site, savings and checking, loans, credit cards, and so forth. All of those buttons share the same perceptual affordances, but the signifiers are needed in order to indicate what the function of each individual button would be. It's worth noting that conventions and standards can emerge over time that reduce the need for explicit affordances. So most users have become accustomed to clicking on text in websites, even if that text is not necessarily called out with affordances like raised buttons or underlines or special coloring or anything like that. So if we look at the Amazon website, we can see that all the navigation options like browsing history, today's deals, gift cards and registry and things like that are not called out in any particular way. In fact, they're not even different from text on here that maybe isn't clickable. However, users have become accustomed to seeing text in certain places and knowing what it will do, so we don't always need to use both affordances and signifiers if we understand what our users expect. However, when we're working in a new domain where maybe the interface standards aren't as well established, we would need to be more careful about using affordances and signifiers together to indicate what actions are possible and what might happen when we do them. This is an example here. This is the Amazon Dash, which is basically just a button is associated with a product that you could reorder by pressing the button. And you'll notice that this device is very simple, provides very little in the way of instructions for how to use it, but relies heavily on affordance, in this case, the pressability of the button, to communicate how to operate it and what the functionality might be. Another important design principle for supporting discoverability and helping users understand how a system works is providing feedback. So users need to know that the system received their input in the first place, but the users also need to know what the system did with their input. Let's look at an example of an interface that does a nice job of providing feedback at multiple levels. So this is an iPhone interface, and they do a very nice thing with the password input. So when you have a password input, one of the things you want to do is you want to cloak the input, usually by replacing the text that the user inputs with dots or stars or something like that, so somebody looking over their shoulder can't see it. However, one of the problems that you often have is that the user themselves is not sure if they've inputted the correct key. So you'll notice that when the user inputs a password on an iPhone, the key that they press is briefly shown, giving the user a chance to see that the system has received the correct input or the input that they gave. And so if they type a wrong character, they can quickly go and correct it. However, after a couple of seconds, that text is replaced by a dot cloaking the interface so that an onlooker can't see it. But there's other levels of feedback that are important too. So for example, if I now sign in, I receive feedback from the system saying that the password that I input was incorrect and giving me options for how to correct it, like replacing it with another password or following the forgot password dialog. Another principle that's important for guiding users towards the correct actions is to provide constraints. And the idea here is that unavailable actions should be disabled, so it's not possible to take an incorrect or unavailable action, and also to limit the total number of options so the selection will be easier, so it'll be easier for users to find the correct actions. So here we return to the stop and start button example to show the principle of constraints. And what we see here is that right now, the start button is not pressable. It's already been pressed in, and so that action is not available. So it's essentially constraining the user to only choose the stop action because that's the only one that's available at this time. Here's another example. This one is from Google Docs. And we can see that when we have a blank document and we select the table menu, the only option that's available to us is to insert a table. The other actions, like inserting rows, inserting columns, and so forth, are not available to us because those can only be taken once you have a table to operate on. And so by constraining the actions that the user is able to take, we're able to keep them from taking an action that won't lead towards the result that they want, but encourages them to take the actions that are available. And finally, an example of limiting the total number of options that will make it easier for people to be successful. And a classic example of this is the Google home screen, which really gives you almost nothing that you can do except for type a search in. So it's very hard to make a mistake on this interface because there's really only one thing you can do, which is type in your search term, and then you actually have two options. You can either perform the usual Google search, or you can click I'm feeling lucky and just have it decide on a search result to give you. We could compare that to, for example, the Yahoo interface, which does provide a search box and a search button, but provides many other options which could distract the user or lead the user down different paths and make it less likely that they would successfully complete the search that they wanted to do. And finally, it's important to support the formation of users' conceptual models so that as they interact with a system, they can learn not only how the specific actions work that they've already taken, but how future actions might work using that system. So if they understand in a grander sense how the system works, they're able to simulate future actions and anticipate what will happen when they do other things with the system that they haven't done yet. And the way that we can form effective conceptual models is to use affordances, signifiers, feedback, and constraints to help form those accurate conceptual models. So here's an example of an old-fashioned air conditioning interface for an automobile. And you can see that the combination of these different interface elements make it fairly easy for the user to anticipate what's likely to happen when they interact with the system. So here we have a temperature slider that fairly clearly indicates what you need to do in order to increase or decrease the temperature. And here we have a fan control, which fairly clearly indicates what you need to do to turn the power of the fan up or down. These interface elements in the middle are probably a little bit more ambiguous, and a user might have to experiment with them or have some prior knowledge in order to figure out what exactly they're likely to do. In contrast, here's an interface that does not provide an effective conceptual model for how to use it. This is an old-fashioned digital watch, and one thing you'll notice about this is that it has these 4 buttons around the outside, which are the way that you control the different modes of the watch. So you could switch it into alarm mode or turn on the stopwatch or change the time or things like that. However, there's no really clear way to map those buttons to which specific actions they're going to do. So the only way that a user can form a conceptual model of this is by trial and error or by reading a manual. Formation of effective conceptual models is challenging and perhaps one of the most challenging aspects of designing interactive systems. And the fundamental problem is that as a designer, we often have a very clear idea of how the system is supposed to work, and we use that when we design the system. However, the user doesn't have the benefit of what's inside our head. They only have access to whatever the system presents in terms of its interface. And through the affordances and the signifiers and constraints and feedback and through trial and error, they develop some model of how the system works. And it's often disconnected from what the designer originally thought. And so coming up with ways to present a system image that supports the formation of an effective conceptual model is challenging, but one of the things that we really need to do when we're designing these types of systems. So as I said, the key tools that we have to support the formation of conceptual models are affordances, signifiers, feedback, and constraints. However, there are two more that we can think about that we can use to support the higher level formation of more sophisticated conceptual models. We need to think about consistency and how to use consistency across different aspects of the system so that what users learn in one place they can apply elsewhere. And we also can think about places to apply metaphor where we can take users' knowledge of other systems and apply them to learning the system that we've designed for them. Metaphors in particular are a very common technique that user experience designers use to try to communicate complex system functionality in a way that users will rapidly understand. Here are some examples of metaphors that are quite common, so common in fact that we probably don't even think of them as metaphors anymore. But the notion of the file and the folder were instrumental in the early days of the desktop metaphor and the early graphical user interfaces to communicate to users how they could save information and retrieve information and how they could group that information in ways that were logical and organize it so that they could find it later. The trash can or the recycling bin is a metaphor that communicates to users how they can discard information but still get it back if they change their mind later. And finally, the most recent of these, the shopping cart metaphor, is a common metaphor that we use on e-commerce sites as a way to communicate to users how they can select things that they want to purchase and go through the process of selecting and separate that from the process of purchasing and choosing shipping and all of those kinds of things. And the shopping cart helps to organize that by giving people a sense of how the shopping process is going to work based on their experience with other types of real-world shopping experiences. In this lecture, we've talked about how we can bridge the gulfs of execution and evaluation. And we've talked about the importance of discoverability, or supporting users' ability to discover what a system can do and how to do it, and the importance of conceptual models, so helping users understand what else the system is likely to be able to do. And we've talked about the roles of affordances, signifiers, feedback, and constraints in helping to support both discoverability and the formation of conceptual models so that we can design systems that will work well for the people that use them. When designing to provide a great user experience, it's important to understand how people perceive information, how they remember what it is that they've perceived, and how people use that information and what they remember to act in pursuit of goals when using a system that you've designed. Often in user experience research and design, however, what we're most interested in is advice on how we can design systems to use the knowledge about people to improve the user experience. And typically that advice comes in the form of guidelines, which are sort of rules or bits of advice about how to design specific types of systems in order to provide a great user experience. And there are lots of different forms that guidelines can come in. And let's look at a couple of examples. So this first example is a set of guidelines that was produced for U.S. government websites. The U.S. government produces a bewilderingly large number of websites, and many of the people producing them don't necessarily have background in user experience research and design. So they created this very thorough and comprehensive set of guidelines for best practices that can be used in designing these government websites. So let's take a look at some examples of what these guidelines look like so we can get a sense of what kind of advice is being provided. Let's look in the navigation section, and we will look at section 4, providing feedback on users' location. And we can see here that the guideline that's being proposed is
provide feedback to let users know where they are on the website. And right below that, there's a little bit more information about why we would do that and how to go about doing it. We can also see good examples of how to do this. So for example, here it's showing an example of a page that highlights the tab that the user is on and shows them where they are, and also uses a breadcrumb to show that that research is a page that's under home and that research overview is under that, and so on and so forth. And we can see some other examples of techniques that are used for showing people where they are on a website. Another interesting thing about this particular set of guidelines, which is not necessarily common, is they've actually shown the importance of each suggestion and the strength of evidence from the research that backs up that particular suggestion. So let's look at another example. This one is the style guide for producing Android apps. And here they're giving recommendations about the size that touch targets should be on a user's screen in order to be accessible to users with different levels of motor control. And they're specifically recommending that the physical size of the touch target should be no less than 9 millimeters on each side in order to accommodate those different users with different capabilities. So these are two examples of recommendations, and you can see that you can produce very specific, very low-level recommendations and guidelines. However, there are some drawbacks to these types of guidelines that make them hard to use in general cases. So one drawback is guidelines like these are very platform specific. So it would be difficult to take the recommendations from the usability.gov set of guidelines, which are designed for government websites, and apply them to e-commerce websites, for example, let alone Android apps or Windows software. Same thing with the Android recommendations. They're very specific to designing mobile applications on the Android platform, and it would be difficult to apply them to other types of scenarios. Another issue with these types of guidelines is because they're so highly detailed, there are a lot of them. So in the usability.gov example, there are over 300 individual guidelines that a designer would have to take into consideration when designing a website using those guidelines. And that can be an overwhelming task, especially for somebody who's just becoming familiar with that particular platform. So you can use any set of guidelines, but it's important to choose the right set for what it is that you're trying to do. And what you might consider when thinking about guidelines that are appropriate for your situation is, first of all, are they well supported and focused on user experience? Or do they have other goals? Are they more about branding for a particular platform or providing an aesthetic experience of a certain type? Do they cover all of the important best practices, or are they just focused on a particular subset of the user experience? Do the guidelines apply to your particular platform or situation? And are they easy to use? Is it something that you'll be able to adopt? Is it a small enough set of guidelines that you can wrap your head around them and you can use them in a way that's efficient for the task at hand? A widely accepted set of guidelines in user experience practice are Jakob Nielsen's 10 heuristics. So this is a simple set of guidelines that can be applied in a wide range of different situations. Heuristic just means rule of thumb, so you could think of them as being slightly more general than a guideline, which means that you can have a smaller set and apply it to a wider set of different situations, in contrast to the specific guidelines we just looked at. Jakob Nielsen's 10 heuristics were derived from a systematic review of usability problems across a number of systems and a number of usability tests, so it has the benefit of being backed up by research and by a systematic process for developing them. It was designed to be a small, complete, and usable set, so they were thinking very specifically about making this something that designers and researchers could use effectively and efficiently across a wide set of systems. In fact, the goal was to be able to teach these heuristics to designers and researchers in just a few hours, though of course you get better with practice. And as we will see, these 10 heuristics are well supported by theories of perception and cognition, such as we've been discussing earlier in this course. And I'm just going to run through these heuristics right now, and in future lectures we'll be going into more depth about each one of them. So don't worry too much if you don't understand exactly what they're talking about right now. So the heuristics are visibility of system status,
a match between the system and the real world, user control and freedom, consistency and standards, error prevention, recognition rather than recall, flexibility and efficiency of use, aesthetic and minimalist design, help users recognize, diagnose, and recover from errors, and finally, help and documentation. And we'll be going into more detail in the next few lectures. Nielsen's first heuristic is visibility of system status. And what this means is the system should always keep users informed about what is going on with the system through appropriate feedback within a reasonable amount of time. So we first might ask, why is this important? Well, knowing what actions are available, so what the system can accept or what actions are possible at this particular time, bridges the gulf of execution, as we've discussed previously. Knowing how the system responded to actions that the user has taken bridges the gulf of evaluation. And this also echoes Norman's principles of feedback and constraints that we discussed in previous lectures. This heuristic manifests in a few different ways in the design of systems, and I'm going to go through them each one by one. So the first way that this manifests is through feedback. And it's important to provide good feedback to actions that users take. And feedback happens at multiple levels throughout the system, and a well-designed system will provide feedback both at the level of very small actions that the user takes, as well as larger actions that support the user's goals. Let's look at a live system to just look at examples of how feedback happens. So if we just were to browse around on Amazon for a moment, we can see many examples of how feedback is used. So for example, when I hover my mouse cursor over these different links right here towards the top, you can see that I get feedback that that link will be selected if I press through that subtle underlining effect that shows up. And you can see many other places where if I hover, I see feedback from the system telling me that it's recognized my action and what it's going to do. And of course, if I click on one of these links, I'm rewarded with feedback showing me that the system has accepted my input and taken the action that I desired. In some places, the feedback is even more explicit. So for example, in Gmail, if I mark conversations as read, I get a banner at the top of the screen showing me explicitly what the result of my action has been. In this case, 12 conversations have been marked as read, and I'm given the opportunity to undo that action if I wish. Another place that the visibility of system status manifests in user interfaces is through showing the user what actions are available at the current time, and by extension, what actions are not available at the current time. So in PowerPoint, for example, when I have text selected in the design window, a certain set of options, such as selecting a font and the size of the font and bolding and adding italics and things like that, are made available. But if I don't have anything selected, those options are not available. If I switch PowerPoint out of presentation mode and into design mode, we can see this example directly. So right now, the options for modifying text are grayed out because they're not available. And as soon as I go over and select some text, they're made available. And this is an example of the system showing me what status it's in terms of what actions it can accept and what I can do at any particular time. It's also important for the system to indicate its general availability to accept any kind of input. And we often see examples of this, especially at the operating system level, where the operating system will indicate that it's busy and it can't accept any input. It might be busy downloading some data or connecting to the network or otherwise engaged and unable to accept our input. And we typically see this through various kinds of changes to the cursor that indicate that it's not going to accept our input at this particular time. When something takes a particularly long time, it can be valuable to present the user with an indication of how far along the process has gotten and allow them to assess how long it's likely to take. So here's an example from installing Windows Update, and here's an example from Chrome of showing how long it will take to finish downloading a large file that the user has downloaded. And there are some general rules of thumb that we can follow when deciding what kind of indicator we should provide when the system is going to take a long time to do something. So here we need to understand how users are likely to react to different kinds of delay. We know, for example, that anything that happens within 100 milliseconds or a tenth of a second in response to a user's action is perceived by them as instantaneous. If it takes longer than that but less than a second, the delay is noticeable, but it's typically tolerable and users will be able to adapt to that delay. If it takes longer than a second, but less than 10 seconds, it starts to get pretty annoying, but most users are willing to wait so that they can continue their task right away. And if something's going to take longer than about 10 seconds, it's better to let the user go and do something else. They're likely to lose focus on the task that they're accomplishing, and they're likely to prefer to go and do something else, like check email, go get a cup of coffee, or do something else while they wait for that process to finish. So we can turn this into a set of general guidelines for what kind of indicator we might use in different situations. So first of all, if at all possible, you always want to strive for a fast response time, which means less than 100 milliseconds. That's not always possible. If it's going to take up to a second, no indicator is needed. You don't really need to change the cursor. You don't need to indicate that the system is busy. By the time the user recognizes the delay will already be over. From 1 to 10 seconds, you want to use a wait cursor. You want to change the cursor into the beach ball or the hourglass or whatever it is on your particular platform to indicate that the system is busy, but it's planning to come back. And if something's going to take more than 10 seconds, you want to complete that task in the background and indicate to the user that it's going to take a while and they should go do something else, and provide them with progress indicators and estimates of how long it will take so that they can plan accordingly. So those are the ways that Nielsen's first heuristic, visibility of system status, manifests in system design through feedback, through showing available actions, and through showing the general availability of the system to users. Nielsen's second heuristic is match between the system and the real world. And what this means is the system should speak the user's language with words, phrases, and concepts familiar to the user rather than using system-oriented terms. Also, follow real-world conventions, making information appear in a natural and logical order. Why is this important? Well, first, it allows us to take advantage of users' existing schema or the associations that they already have between different pieces of information and how they're connected to goals and actions. It also allows us to leverage perceived affordances and signifiers that suggest actions that are familiar to the users. And it reduces the difficulty of forming effective conceptual models because we're taking advantage of conceptual models that users already have. And again, there are a number of different ways that this heuristic manifests in specific designs. The first is through the use of language. So the heuristic says use words and phrases that are familiar to the user, not system-oriented language. We often see examples of error dialogues and other dialogues that have traces of the programming that was done to produce the system that haven't necessarily been rewritten to make sense to users. So here are a couple of examples. Microsoft Office Update doesn't understand the event sysodis-a message. This is clearly not a message that was intended to make sense to the user, but maybe it makes sense to the person that programmed this particular system. Or here's another example. This is actually an example from an earlier version of Twitter where the message simply says error, node was not found. This is not something that's going to make sense to the user, and it's going to impede their ability to use the system or understand why whatever they did failed. Here's another example. This is a system called the Text Analysis Markup System, or TAMS for short. And this is a very specialized tool that's used for people that do certain types of research using qualitative textual analysis, which isn't very important to understand. But if we look at the language that's used on this interface, we can see lots of examples where system terms continue to show up that might make it hard for people to understand how to use the system. So for example, init file, or path mode, or define codes, or various things like that are defined in terms that aren't going to necessarily be obvious to the users or be part of the user's vocabulary, but are going to be part of the vocabulary that makes sense to the system developer. By using system-oriented language, it's going to be harder for users to learn how to use this system and to master it. So here's another example. Think about how you might create a document in the real world. You might pick up a piece of paper. You might write some stuff on it, maybe a letter to somebody, a memo, a note that you want to remember, a list. And only at that point do you decide if this thing that you've produced is valuable enough to save or whether it should be crumpled up and thrown in the garbage or recycling. Well, a similar order of operations has evolved for how we create digital documents. So you start by creating the document, which is a blank page, and then you write some stuff on it. At that point, you decide whether this document is worth saving, and if so, you save it, and then you give it a name and decide where to put it. You could imagine systems that ask you to name the item first and choose a location for it, which would end up forcing you to create a bunch of documents that you end up not needing that just clutter up your desktop, your file system, and so forth. To extend this a bit further, a common way that the match between the system and the real world is manifested is through the use of metaphor, which we've talked about in earlier lectures. The two examples that I just gave are often embodied in digital systems through the shopping cart metaphor and the document metaphor. But these metaphors go farther than just suggesting a particular order of operations that might be used to complete a particular task, but allow the user to infer other capabilities that might be available through these system functions. So for example, the user might infer that the shopping cart would also allow them to add multiple items and to remove items and even to abandon their cart without buying anything. The document metaphor might suggest to users that they not only can create and save files, they can also delete them, they can copy them, and they can send or share them with other people. It's important to make sure that systems that we design match the real-world expectations of users so that they can take advantage of what they know from the real world and use it to effectively use the systems that we design. Our third heuristic is user control and freedom. So users often choose system functions by mistake and need to be able to get out of the state that they've gotten themselves into through a clearly marked emergency exit or something similar. Also, it's important to support undo and redo so that people can roll back unintended actions and get back to a previous state. Why is this important? Well, first of all, mistakes are inevitable. No matter how perfectly you think you've designed your system, people will make mistakes with the system, and you need to support that and allow them to recover from those mistakes. Second, we need to support the 7 stages of action by allowing users to reformulate their goals and abandon something that they started in order to pursue a new goal, perhaps because they've learned that they wanted to do something different in order to accomplish their goal than what they initially anticipated. We also know that users employ trial and error to learn a new system. So sometimes they try stuff out just to see what it will do, not because they actually want the system to do that particular thing. So let's look at a few examples of how user control and freedom manifests in system design. So the first is through what Nielsen called emergency exits. So if the user has embarked upon a particular interaction and realized that it's the wrong interaction or it's going to take too long, we need to provide them with a way to get out of that. So in this example, the user may realize that they don't have time to install the updates or they don't want to install these updates, and so they have the ability to stop the installation and just go back to what they were doing before. And the second way that user control and freedom manifests in system design is through the support for undo and redo. So undo simply allows users to roll back or undo the results of an action that they've taken and get back to a previous state. And redo is important because sometimes the undo is the mistake that the user needs to recover from. And we see undo and redo implemented at multiple levels throughout computing systems, whether it's undoing changes to text formatting that we might have done in word processing software, or whether it's undoing the deletion of a file or data that we might have done at the operating system level. The important message here is that it's important to allow users to remain in control and give them freedom to make mistakes and recover from those mistakes. And we need to do that through implementing emergency exits and undo and redo functionality. Nielsen's fourth heuristic is consistency and standards. And he says users should not have to wonder whether different words, situations, or actions mean the same thing. Also, it's important to follow platform conventions. Why is this important? Well, again, this allows us to leverage users' schemas. So allow them to take advantage of patterns of interaction and patterns of information organization that they've learned from using one system or one part of a system and apply it to a new system or a new part of that system. Being consistent allows us to present a coherent conceptual model, which makes it easier for users to learn how to operate the system effectively. Consistency and standards show up in a number of different places in the design of systems. So firstly, it shows up through the consistency of language, layout, and behavior. When designing systems, we often have many choices about what to call system functionality. We might decide whether to call a particular function search or submit query, or save versus commit, or create versus new ... And while it's important, as we learned in an earlier heuristic, to use terms that are familiar to a user, there might be many terms that would work in a particular situation. What's important here is that you use the same term in the same way throughout the system, so the user doesn't have to wonder if save means the same thing as commit, or whether search means the same thing as submit query. And if they mean different things, they should actually do different things so the user can learn what those different things are. Consistency applies beyond language, however, also to layout and behavior. And to look at a good example of how consistency can be applied, let's look at Amazon.com. So if I look for different types of products on Amazon, so let's say in this window I look for coffee makers, and over here I look for running shoes. You see that there's some slight differences in the way that the search results are displayed, but they're by and large fairly similar. But if we look at the individual products, so if I click on that particular coffee maker or that particular running shoe, you can see that the same type of information is presented in the same organization in both of these cases, even though they're different types of systems. So we can see a picture of the item. We can see different pictures to look at different views of the item. We can scroll and see similar behavior for zooming in both cases. We see the ratings, we see the price, and all of these things in the same organization, so that if I've learned how to look for information about one type of product on Amazon, I can use that to look for other types of products and other information about those products, even if they're completely different types of products. It's also important when designing a series or a suite of products to maintain consistency across those products. And we looked at this in an earlier lecture, but for example, looking at the different Google apps for word processing and for spreadsheets, we see that a very similar layout is used for the menu bar and the formatting options. So we see the same menus appear in the same order: File, Edit, View, Insert, Format, and the same thing appears down here. And we see that similar formatting options are also visible right under the menu bar. And this allows a user that's learned how to use one of these apps more rapidly learn how to use another app and gain productivity with that more quickly. As a result, it's often beneficial for competitors to borrow the design elements and the design patterns from each other so that users who are switching to their product can more easily learn how to use those products. So if we look at Microsoft Word Online, we see some of the same elements and some of the same arrangements. So we see the menu here, slightly different options, but we know where to look for those particular options, and we see formatting appear in the same place as it does in both of these products. And of course, I do realize that Microsoft Word came before Google Docs, but I think you get the point I'm trying to make. Finally, when looking at consistency and standards, it's important to follow platform standards or platform conventions wherever possible, unless you have a really good reason to do something differently. Let's look at a couple of examples of websites that don't follow platform conventions and not necessarily to a good effect. So this is a website that sells a unique kind of housing called a flat pack house that can be rapidly constructed in lots of different environments. But their website doesn't follow standard web conventions for navigation. So when looking at this, we can see that there's news in the center, but it's not clear where else you can go on this site. In order to figure that out, you actually need to hover over the numbers. And we see the navigation options now, what is Flatpak, how to Flatpak, and so on and so forth. And it doesn't necessarily get better when I click on one of these items. So if I click on number 2, how to Flatpak, I'm also presented with an obscure, difficult to read set of navigation options that I then need to go and further interact with in order to see what the options are. So by deciding not to follow platform conventions, these website designers have created a system that's harder to use and harder to learn for somebody just coming to the system for the first time. And while I was eventually able to figure it out, it wasn't clear or intuitive, and it presented a usability barrier to me and I presume to other people that would be coming to this site. Being consistent and complying with standards is very important when designing systems. We need to be consistent within the system, so across different parts of the system, consistent across different related systems, and consistent with what users expect from interacting with other systems on the same platform, whether that's the web or a particular mobile operating system or installed software. By being consistent, we can help users more rapidly learn to use the system that we're designing by taking advantage of what they've learned from using other similar systems in the past.
Nielsen's fifth heuristic is error prevention. So even better than good error messages is a careful design which prevents a problem from occurring in the first place. Either eliminate error-prone conditions or check for them and present users with a confirmation option before they commit to the action. Why is this important? Well, first of all, mistakes are common. People will make mistakes, as we discussed in an earlier heuristic, and we want to try to prevent them as often as possible. As we talked about earlier in the course, people don't see or read everything on the screen, so you can't assume that just because you gave them the information they needed to do something correctly, that they're actually going to notice that and do it correctly. And people make mistakes just all the time when typing, clicking, etc., even if they understand what it is that they're trying to do. So what are some different ways that we can prevent errors in designing user interfaces? Well, one is we can provide constraints that guide people towards the correct actions. So let's give an example. So imagine a form where you're asked to enter your birth date or enter some kind of a date. And if the form field looks something like this, you might enter something, and then more often than not, you're presented with an error that says, oh, actually, we wanted it in this particular format, month, day, year, and so forth. So how could we do a little bit better? How could we prevent that error from happening in the first place? Well, one way might be to provide the information as part of the prompt. So we actually now are asking them to enter their birth date, but we're telling them the format we want it in. But remember, people don't always read that carefully, so many people might still get this wrong. So a third way that would even be an improvement upon this is to provide constraints. So what we've done here is we've actually broken the data up into 3 different fields, and by the size of the fields, we're showing the type of information that we're expecting in each one, and we're labeling each of the fields with the information that we're expecting. So
The first one is not so good. The second one is a little bit better, but the last one is even better than that. But there's techniques that exist to make this kind of experience even better. And one of those techniques is in-process feedback, or feedback that is given to the user as they go through the process of filling out a form. And this can be done with technologies like JavaScript, for example. I'll show you an example of what happens when you sign up for a Twitter account, and look at what happens when you enter incorrect or invalid information. So I'm going to enter my name, but then I'm going to enter a bogus email address, and I'm going to enter a short and insecure password. And you can see that even before I click the sign up button, I'm presented with feedback telling me that the input that I've given is invalid. So it prevents me from entering erroneous data before I've even gone to the point of clicking sign up or completing the action. Another way we can prevent errors before they happen is ask people to confirm that this is what they really wanted to do when it's a particularly risky operation, or perhaps one that can't be undone. So for example, on a Macintosh, if you empty the trash, that means that you're deleting data that you can't get back. And the operating system will ask you to confirm that this is what you really want to do and give you the warning that you can't undo this action. So it asks you to confirm this action, which is potentially risky, before it does it. And another example is, wherever possible, you can just prevent actions that are likely to fail. So in this example, which is a screenshot from the Android operating system, I was not allowed to update the system because I didn't have enough battery to complete the update. And the system designers knew that if the update failed in the middle, because the battery ran out, that it would cause corruption to the system. So it didn't even allow me to do that. So the key here is, wherever possible, you should try to prevent errors before they even happen, rather than just waiting for them to happen and helping users recover from it. Heuristic number 6 is recognition rather than recall. You want to minimize the user's memory load by making objects, actions, and options visible. The user should not have to remember information from one part of the dialogue to another. And instructions for use of the system should be visible or easily retrievable whenever appropriate. Why is this important? Well, as we've discussed in earlier lectures, a familiar stimulus triggers retrieval from long-term memory. So if the user recognizes something on the screen, it will be easier for them to remember that that's the action that they need, or that's the option that they need to take, rather than having to recall it from long-term memory. Because if they have to recall it, it will force them to recreate the chain of associations themselves, rather than having it provided to them, or it will force them to have to learn through elaborative rehearsal what the commands and operations are that they need to perform. And recall will fail unless the actions or the information that users need to remember are frequently used, recently used, or strongly associated with information that they already have. So let's look at an example of how recognition rather than recall is used in user interfaces that you might be familiar with. Let's say I wanted to make this dot on the screen animated. I wanted to make it move around. I'm going to switch into edit mode. So what I'm going to notice is this text right up here at the top that says animations. And so I can recognize that that's where I probably need to go in order to perform this operation. When I click on the Animations tab, I'm presented with a whole set of options that I can choose from that will allow me to animate this dot in different ways. And again, I can recognize the option. I can decide, do I want this to fly in from the side? Do I want it to peek in? Do I want it to just appear? Or whatever it is, rather than having to remember or recall the command that would perform the operation that I need. What we just saw is an example of a direct manipulation interface, which is the style of interface that most graphical user interfaces use. A direct manipulation interface provides all of the objects that we might want to manipulate and all of the operations we might want to perform as visible options on the screen so that we can always recognize what it is that we need to do rather than having to recall it. And most interfaces work this way, and you want to make sure that your interfaces do as well. There are a few places, though, where recall is still a part of a typical user experience. One of these is interfaces that require us to remember textual commands that we type into a system. The most common place that this is seen is in command line interfaces, such as this one shown here, where the user needs to remember command syntax like cd for changing directory, ls with these options for listing the contents of a directory, and all this junk down here for listing the running programs and searching through the list and so on and so forth. And an interface like this just requires the user to recall and memorize all of these commands and the options for these commands and so on and so forth. Another place that recall comes up in typical user interaction is with passwords. And this is for very good reason. We don't want to display users' passwords on the screen. However, it's worth keeping in mind that this is a place where users are going to have to memorize something, and as designers, we can make that easier or harder through how we present passwords and what rules we put around the passwords that people are allowed to use. Finally, an area of user interaction that we're seeing more and more often where users have to rely on recall rather than recognition is with speech user interfaces. So for example, when interacting with Apple's Siri, Siri asks me what I can help you with, and I need to either guess or remember what commands I can issue that will get Siri to do something for me. If I wait a certain amount of time, Siri will come back with some suggestions. Here's some things that you could ask me. What's the news for Chicago? Show me my tweets and so on and so forth to give me some clues about the language that I can use. But ultimately, it's going to be up to me to recall how to interact with Siri because I can't recognize it from things that I see on the screen or for things that Siri says to me. So to sum up, we want to use recognition, not recall, wherever possible. And if recall is required, ask yourself, is it realistic to expect users to remember what you're asking them to remember? And are cues provided if recall fails? The seventh heuristic is flexibility and efficiency of use. So accelerators, which are unseen by the novice user, may often speed up the interaction for the expert user, such that the system can cater to both inexperienced and experienced users. Allow users to tailor frequent actions wherever possible. Why is this important? Well, while we've said before that recall is problematic for new and infrequent users, it can be very fast for experts who have actually learned how to use the system, who know what they need to do and want to do, and are able to do it quickly. Also, different users have different goals, so you want to allow them to customize their experience to make it more efficient, but it's important not to force them to do so. So Nielsen talked about accelerators, and accelerators are things like keyboard shortcuts that can make it much more efficient to do common actions like cut, copy, and paste. So in designing a system like a word processor, you want to allow recognition by providing those options in the menu so users can explore the menu, they can see what the different options are, but also provide expert users with a fast way to do it by learning shortcuts like Command X, Command C, and Command V. By providing users with the capability to add shortcuts and bookmarks, you can make it possible for them to accelerate their own experience. So for example, most web browsers offer the bookmark capability. So common pages that you visit, you can bookmark. And of course, these bookmarks are going to be different for different people and provides a way to accelerate common actions that you want to take. So if I wanted to bookmark this page, which is Michigan Online, the University of Michigan's online course listing page, I can add that as a bookmark. Bookmark this page. And after that, it's going to appear on my bookmarks bar, and I can easily go back to it. And many other programs offer the functionality or functionality like this to add bookmarks or shortcuts to make common actions
faster for users.
Another example of how we can make interaction more efficient is to offer personalization. And this is a way to automatically create shortcuts based on users' past behavior that allows them to repeat actions that they're likely to take again in the future. So for example, if we look at my Amazon homepage, or the page that I see when I visit Amazon, we can see that it's been personalized to me by presenting me with options that are either things that I've looked at recently or that are related to things that I've looked at recently. So it makes my shopping experience more efficient by presenting me with things that are more likely for me to want to look at than forcing me to go through the general search and browsing experience that I might otherwise have to go through. So while it's important to support new users or infrequent users of a system by prioritizing recognition over recall, it's also important to support expert or repeat users of a system by supporting flexibility and efficiency of use, which we can do by providing accelerators, allowing for shortcuts and bookmarks, and providing personalization where possible. Nielsen's eighth heuristic is aesthetic and minimalist design. And he says dialogues should not contain information which is irrelevant or rarely needed. Every extra unit of information in a dialogue or on a screen competes with the relevant units of information and diminishes their relative visibility. So why is this important? Well, as we've said before, people don't read everything that's on a screen. And the more stuff there is on the screen, the more likely it is that they're going to miss something that's actually important. So visual clutter makes it harder to find and focus on the desired actions and the desired information. Good use of color, shape, motions, and Gestalt principles can guide the eye towards that important information. So this is the aesthetic part of the design. And in general, the more there is to see, the less of it users will actually see. So in order to support this heuristic, the first thing we want to do is reduce clutter as much as possible. And let's look at a couple of examples of how this is done. So to bring back this example, which admittedly is somewhat extreme, you can see that the visual clutter on this page makes it very hard to figure out what's going on, what information is relevant, and what actions are available to be taken. Let's contrast that with another admittedly extreme example, the Google homepage, where there's very little to distract the user from the primary task that they want to accomplish, which is conducting a web search. When you do have a lot of information to present and you are sure that it's of value to the user to do that, it's important to use Gestalt principles to support nonlinear reading of the page. So use aesthetic design to organize the page in a way that makes it easy for the user to skim through, skip around, ignore the information that they don't want, and get right to the information that they do want. So in this example, there's quite a bit of information, lots of different products to choose from, lots of different navigation options and so forth across the left side and across the top. However, it's organized in such a way that it's very easy for a user to scan the page and get right to the part that they're interested in. By making use of the visual principles that we've talked about earlier in this course, and by reducing visual clutter as much as possible, we can make it easier for users to find the information and the opportunities for action that they need to find in order to have a better user experience. Our ninth heuristic is help users recognize, diagnose, and recover from errors. Error messages should be expressed in plain language, no codes, no programmer speak, precisely indicate the problem, and constructively suggest a solution. Why is this important? Well, really, this heuristic is a special case of a bunch of other heuristics that we looked at earlier. So heuristic number 1, make system state visible and give users feedback. So this is an example of giving users feedback about errors that might have occurred. Number 2, speak the user's language or have a match between the system and the real world. So this accounts for the need to express errors in language that the users will understand. Heuristic number 3, allow users to undo and escape from mistakes. So when an error does occur, we want to provide users with information that will help them escape or undo those mistakes. And finally, number 5, we want to prevent and detect errors. So this is related in the sense that sometimes you're not able to prevent errors, even if you try, and you need to help users recognize that they've happened and help them recover from them. So an important part of this heuristic is make sure that any error messages that you display to the user make sense to them. So here's an example of a page not found or a so-called 404 error on the Airbnb website. So if you accidentally try to visit a page on Airbnb that doesn't exist, this is the screen that you see. And it provides useful information and makes clear what's happened by telling you that it can't find the page that you're looking for, and it offers you some helpful links that you can go to instead. Let's contrast that with a more generic page not found error like this one, which mostly consists of codes and language that a typical user isn't necessarily going to be able to make sense of. The requested URL was not found on this server. Additionally, a 404 not found error was encountered while trying to use error document, and so on and so forth. This is much less helpful, much less constructive in terms of helping the user fix the error or get to something that is going to be useful for them. I think we've all experienced error messages from software that doesn't make sense and doesn't feel very constructive, and it can be very frustrating. So we might see error messages like Microsoft Office 2008 update doesn't understand the event sysodis A message. Well, that's not helpful and it doesn't make any sense to me. Or a message that says simply error, node was not found. Well, that doesn't really help me understand what I did wrong, how to avoid it in the future, or if it's something that I need to fix. More helpful error messages will provide more information about what happened so I understand what I did that caused the error in the first place, and will also provide suggestions about how to fix the problem or how to accomplish what it is that I'm trying to accomplish. So in the example on the left, I've tried to register for a service that I already registered for. And when I registered, it sent me an email. And now what I need to do is go verify my email address by clicking a link in that email. And so this error message tells me that I'm already registered, tells me the next step that I need to take, which is to verify my email address, and also gives me another suggestion in case I've lost track of that email, which is that I can request a new email. So it provides me with several helpful suggestions that can get me unstuck and off of this particular problem. In the example on the right, I'm trying to open a file that my software doesn't understand, and the error message tells me that I may need to install additional software, and also provides a Tell Me More button that will give me more information about how to install software, what software I might need to install, and so forth. So ideally, we want to prevent errors before they occur, but sometimes we're not able to do that. And so in those cases, we want to make sure that we help users recognize those errors, diagnose what the problem is, and offer suggestions about how they can recover from those errors and get going again on the task that they need to accomplish. Our final heuristic refers to help and documentation. Even though it's better if the system can be used without any documentation, it sometimes may be necessary to provide help and documentation. Any such information should be easy to search, focused on the user's task, list concrete steps to be carried out, and not be too large. Why is this important? Well, in some cases, your user interface may not be as self-explanatory as you hoped it might be. The guidelines in this heuristic about the structure of help and documentation are there to help support the gulf of execution. So that's why help needs to be easy to search so that people can find the help that they need. Needs to contain the list of actions so they know how to apply the help to solve their problem. And it needs to be focused on users' tasks, because we're trying to help bridge that gap between users' goals and how they can accomplish those goals using this particular interface. To look at an example for how help and documentation can be focused on a user's tasks, I'm going to go back into edit mode and look at how PowerPoint organizes their help files. When I open PowerPoint Help, I can see that the first two options that are presented to me describe tasks that I, as a user, am likely to want to perform, like creating a presentation and adding and organizing slides. The next few items are more generic, but if I drill into them, I can see that they too are organized in terms of tasks that I'm likely to want to accomplish, like changing or removing a theme, creating and applying my own theme, and so forth. And to look at how help can be organized into step-by-step instructions, we'll look again at PowerPoint help. So if I look at a particular help item, let's say I look at adding and organizing slides, I want to add text to a slide, I want to add text to a text box, the actual help content is organized into these step-by-step instructions that will allow me to accomplish my task. One other technique that can be used to help users find the help that they need as quickly as possible is contextual help, or help that is specific to the particular tasks that people are trying to perform. For this, let's look at an example from Eclipse, which is a programming editor and development environment that I use sometimes. So here we see the Eclipse environment, and there are several different areas on the screen. On the left, we see the area that organizes the different code files that I'm working on. The center shows the specific file that I'm working on, and it provides editing capabilities. And then there's other screens as well. If I click in the editor to set the focus on that part of the screen, and then select Eclipse's dynamic help, this streamlines my search for help by focusing it on the things that I'm most likely to be interested in based on the tasks that I'm performing right now at this moment. To summarize this heuristic, it's best if help and documentation is not needed. Ideally, your interface is intuitive and clear enough that people know what to do without help. But sometimes, especially in more complicated software, help and documentation is required. If it is, make sure that the help is searchable, focused on the user's tasks, and provides concrete steps to help them accomplish the things that they need to get done. In previous lectures, we've talked about Nielsen's 10 heuristics for good user interface design. In this lecture, I'm going to introduce a way to use these heuristics right now that you could employ to improve a user interface that you're working on. It's a technique called heuristic evaluation. And this is a discount user experience research method, so called because it's cheaper and faster than usability testing, which is usually considered the gold standard for finding problems in a user interface design. And it's cheaper and faster because you don't need users. Instead, it's an inspection method, which means that you perform a systematic, close read of a user interface and apply the heuristics that we've just been talking about to find and explain problems with the interface. The way it works is you choose a set of screens or interactions that you're going to focus on. This could be an entire system, or it could be a subset of a system that is one that you really want to pay attention to. You then step through those screens and that interaction, applying the heuristics to find potential problems. You need to remember to test error cases because there are some heuristics that look specifically at errors and preventing them or helping users recover from them. And you also need to be sure to look at the help system and how that's accessed if there is a help system. You're going to write down all the violations of the heuristics that you come across, no matter how big or small they are. You're not going to worry too much about that in the first pass. And you're going to write down the heuristics that they violate. You're also going to assess the severity of each problem. Is this a problem that's going to prevent users from completing their tasks, or is it something that's just going to annoy them? And finally, you're going to create a prioritized list of the problems, the most important problems that need to be fixed. So I mentioned that you need to assess the severity, and here's a rating scale that's often used in heuristic evaluation. That's just a 4-point rating scale, ranging from 1, which represents a cosmetic problem, no real usability impact, so something that's maybe just annoying, to 4, which is a usability catastrophe, absolutely imperative to fix because users will not be able to make successful use of the system if that problem isn't fixed. So here's an example of the kind of problem that you can find with a heuristic evaluation and how you might communicate that to the designer of a system so they will know what needs to be fixed and how to fix it. So the finding is that the total duration or time remaining is not displayed in the video player that's embedded in this particular site. The severity of this issue has been rated a 3 out of 4, indicating that it's a pretty serious problem, but it's not necessarily a showstopper. The heuristic that's been violated is the visibility of system status, because the user is not able to tell how much of the video they have seen and how much is left. A more detailed description is offered, saying that the videos in the courses do not have the total duration displayed, explains how this violates the heuristic of visibility of system status. While there is some indication of the progress through the video, it's not enough for a user to plan their work and make sense of how much time is left. A screenshot is offered to indicate precisely where in the interface this problem occurs. And finally, a recommendation is offered about how this might be fixed. In this case, it's very simple. Simply add the total time remaining so that users can understand what's going on. When performing a heuristic evaluation, it's not uncommon to come up with dozens of violations of heuristics in even a simple interface. However, a really long list of problems can be less useful when trying to decide what to fix than a short list of the most important problems. So the next thing you want to do after assessing the severity is prioritize. You want to pick out the top 5 to 10 problems and highlight them and rank them in decreasing order of severity, with the most severe problems showing at the top and less severe problems as you go farther down. You also want to make sure that you use the heuristics to explain why they matter, especially if you're working in a team, you're trying to communicate to decision makers or designers about not only what the problems are, but why they're a problem and why it might be important to fix them. Whenever possible, when performing a heuristic evaluation, it's better to have multiple eyes looking at the same thing rather than just having one person do it. Research on heuristic evaluation has shown that on average, one evaluator will find about 35% or a third of the true problems that would be found with a full-fledged usability test. If you add more evaluators, you find more of the problems. So when you get to 5 evaluators, you're able to find, on average, about 75% of the problems you would find from a usability test. Once you go past 5, you don't get that much more bang for your buck. So 10 evaluators only find 85%. So now you've doubled the number of evaluators from 5 to 10, but you've only found 10% more of the problems. So the sweet spot is really between 3 and 5 evaluators. If you can get a team of 3 to 5 people to all perform their own independent heuristic evaluations of an interactive system, and then pool together the problems that they find and agree on the severity and the priority, you can do a very good job of approximating what you would learn from conducting a full-fledged usability test. However, solo evaluation or evaluation by an individual can still be very valuable. You can still find about a third of the problems that you would have found from a usability test, and usually you're going to find the most important problems. Heuristic evaluation is often used as a proxy for user testing. The advantages are that heuristic evaluation is generally cheaper, faster, and you don't have to use up potential users. Sometimes recruiting can be difficult, and you want to save your users for when you have a system that's closer to being ready or where you need the information that you can get from a usability test. User testing, on the other hand, is more realistic. You generally find more problems than you find through heuristic evaluation, and user testing allows you to assess other user experience qualities beyond usability, such as usefulness, desirability, and so forth. In fact, both heuristic evaluation and user testing, along with other UX methods, are typically used in an iterative design and evaluation process. So for example, you might perform user testing early in the process to make sure that you're on the right track, that you have the right functionality covered. And then as you get a more refined prototype, you might perform a heuristic evaluation to kind of shake out the bugs in the design that you've produced. After you've fixed those bugs and you want to see if you really got it right, you might perform more user testing, and you might go around like this, using multiple methods to try to zero in on the problems and what's most important to fix. To sum up, heuristic evaluation is a quick and inexpensive method to find significant flaws in a user interface. To perform a heuristic evaluation, you use Nielsen's heuristics, you inspect each screen or each state of the user interface, including erroneous inputs and the help system, document each violation, and assess the severity of those violations. And then you prioritize the biggest problems that you found and document them in a way that will help guide further development and further improvements of the user interface. In this course, we've been talking about principles for designing for humans. We've started from what psychology tells us about how people perceive and process and remember information, and then drawn connections to principles for how to design effective user experiences. Most of what we've talked about in this course focuses on the usability of user interfaces. As we know, usability is one of the core elements of user experience. And even just with respect to usability, there's a lot more that we could have covered, but we didn't have time to get to in this course. To go deeper into this area, you might pick up a copy of Don Norman's Design of Everyday Things, which we talked about in some depth throughout this course. In the actual book, he goes into more depth on the stages of action and the gulfs of execution and evaluation, and also more depth on the principles to support discoverability, like feedback and constraints, affordances, and so forth. Another book that I find really useful is Designing with the Mind in Mind by Jeff Johnson. And in this book, he starts with the principles of human psychology, including several of the ones that we talked about and other ones as well, and maps them into concrete design do's and don'ts with lots of great examples. And if you want more on the design principles for creating good user interfaces without as much depth on the science behind it, Steve Krug's Don't Make Me Think is a very approachable, very helpful reference for specific design principles around web and mobile usability. But usability is only one component of user experience, and unfortunately, we didn't have enough time in this course to get into all of the different components. When thinking about value, unfortunately, there isn't much we can say that generalizes across the board to different types of people. Different people have different needs, and for each system that you're working on, you need to understand those specific needs in order to make sure that the system addresses the needs that the users have. So while there are no magic solutions, there are well-known methods that help us understand users' needs and how to design systems that satisfy them. One text that I recommend in this regard is Observing the User Experience by Goodman, Kuniavsky, and Moed. And while we haven't talked about how to design for desirability in this course, it is an important topic, and I'd like to give you some suggestions about how you might start looking into and thinking about this topic with regards to user experience. One suggestion is another book by Don Norman, a sort of follow-up to the Design of Everyday Things, where he talks about how users respond emotionally to designs. And he talks about, for example, 3 levels of emotional response that we have, ranging from the visceral, which is the fast, primitive response that we have to things like colors and motion and how that impacts an emotional response that users have. The behavioral level, which is based on use, which is most closely related to the types of usability-focused principles we've been talking about here. To the reflective level, which is based more on associations that users make between a system and things like their underlying values or other systems that they use or have used in the past, or reflections on themselves and their identity and how a system does or does not contribute to their sense of self. And a number of authors have written about the role of aesthetics and beauty in user experience design. One good example is an article that Mark Hassenzahl has written for the Encyclopedia of Human-Computer Interaction, which is on the Interaction Design Foundation website. You can find the link to this at the bottom of the screen. He talks about how experience is an inseparable, meaningful whole, and how experience becomes relevant through remembered stories. So the stories that we tell ourselves about our experiences become the meaning of those experiences. And he also talks about how there's more to experience than can be understood by looking at product features or by just looking at things like usability. Increasingly, when we design interactive systems, we're not just designing products that people use, but we're actually designing and sustaining relationships between the provider of the service and the user. Many designers are talking about service design as a complement to user experience design that looks specifically at those relationships between a service provider and a user and maps out things like the customer journey that describes how a user starts to use a service, how they progress through using the service, and even how they come to the end of their relationship with a service provider. Service design also gives us the notion of multiple touch points, different user interfaces or different physical interactions that users might have with a service provider, and how those touch points need to be designed to be consistent with each other and to provide a complete picture of the relationship. And the fourth component of user experience is adoptability, which refers to how easy it is for users to find and access and begin using a product or service. An important aspect of adoptability is accessibility. How easy is it for users with different motor and sensory and cognitive capabilities to access a system and get done what they need to get done? Accessibility is a huge area. It's probably worthy of its own course, at least if not several courses. Even the subfield of web accessibility, so just how do you design websites so that people with different capabilities can access them, is big and constantly evolving. As a way to get started thinking about accessibility and how you can include accessibility in designs that you do, I can recommend this video from the University of Washington. It focuses specifically on web accessibility, but a lot of the principles that they describe apply more broadly to other types of systems that you might develop as well. In this course, we've been talking about principles for designing for humans. We've done that through understanding human perception and cognition. How do people perceive the world around them, and how do they make sense of that information and remember it for later use? Based on that knowledge, we've been looking at design principles that you can employ for making sure that systems that you design are usable by people. We've introduced an inspection method, heuristic evaluation, that you can use right now to improve systems that you're working on. And I've given you some pointers for how you can explore this very large topic further. Thanks for being part of this course, and I look forward to seeing you in future courses as well. So we use a lot of different methods in UX research, but it's useful to think of really three basic methods or approaches that encompass pretty much everything that we do in UX research. So there are really three basic methods that we use in user experience research to guide a product towards a great user experience. We can ask people what they do and what they think. We can observe what they do. And we can inspect prototypes and artifacts to determine whether or not they're likely to deliver a good user experience. When we talk about gaining insight through asking, there are a number of different specific methods that we use. By far the most common are interviews and surveys. Interviews consist of conversations with stakeholders to understand aspects of their experience. And surveys consist of questions that are distributed to lots of people to elicit information about their attitudes, behaviors, and characteristics. There are other methods that we're not going to go into right now, like focus groups, diary studies, and experience sampling. When we talk about gaining insights through observations, there are a number of different specific ways that we do that. One is through ethnographic observations, which basically consists of hanging around in particular environments while people are performing activities and watching people engage in those activities to understand how they go about them. We can also observe how people interact with prototypes and systems that we've developed by asking them to perform scripted tasks to see if a system supports them through user testing. And after a system is built and has been deployed in the wild, we can employ usage analytics, often called web analytics or mobile analytics, depending on the platform, to analyze large-scale traces of system usage to understand the patterns of use. And again, there are other techniques that are more specialized, like video analysis and social media mining, that we won't go into, and there are others as well. And finally, when we talk about using inspection methods to gain insight, there are a couple of different ways that we do that. We can perform guideline-based inspections where we compare a system design against known best practices to find places where it probably breaks down because it violates some principle of what we know is likely to work for people in a particular context. We can also perform walkthrough-based inspections where we step through an interaction sequence using specific techniques to take a user's eye view to find probable breakdowns. And we also can perform comparative analysis where we systematically compare a design with similar designs to identify strengths and weaknesses. And we often combine these different approaches in specific methods. So in user testing, we not only observe people performing tasks, but we usually accompany those observations with interviews to get more information about people's reactions to the product and learn more about what works and why. And we also combine watching and asking through contextual interviews, often in the early stages of a design project where we ask questions of users while observing their natural activities take place. So we might sort of watch over their shoulders as they perform tasks using their current systems and ask them why they're doing things and what works and what doesn't. And there are, again, other techniques like artifact-based interviewing that would employ a combination of watching and asking, which we aren't going to say much about here. So a question might be, when do you use which of these different techniques? Well, at a very high level, we probably want to use asking techniques where we're interacting and having conversations or asking questions of members of our target population when perhaps observation is infeasible. Maybe these are activities that are infrequent or take a very long time to unfold or are private and not things that we can easily observe. We want to ask questions when values and motivations are key because these are not things that are easy to get out of an observation where you can't find out why people are doing things. And we specifically employ surveys when we need to get large numbers of responses and a high degree of certainty, where we can employ statistical methods to be able to make strong claims that particular characteristics are present in our user population. We want to lean more towards observation when self-report will miss information, perhaps because of the frailty of human memory or because there's tacit knowledge involved that people will not be able to tell you about in an interview or a survey. We want to conduct observations when process and communication are important, where it's very important to see how people go about doing things and how communication with other participants in the activity is critical to the way that people conduct these activities. And we specifically employ techniques like analytics, again, where large numbers and high certainty are needed. And we want to perform inspections when, first of all, you have a product to inspect. So inspection methods don't work early in the stages of a design project where you're understanding users and their current practices and trying to understand what the possible options for a solution are. But once you have a prototype, you can perform things like guideline-based inspections and walkthroughs. Inspection methods are also useful when interacting with users is too expensive or cumbersome, perhaps because users are difficult to recruit or you're simply not at a point in the design process where it makes sense to invest in those kinds of methods. And the critical thing to realize is that you will use all of these methods in a typical design project. So for example, and this is just one example, every project is different and they all unfold differently. But for example, you might start out at the beginning of a project in the assessment phase by conducting interviews where you try to understand what it is that users are doing, why they're doing things the way that they do, and you might follow that up with observations where you try to understand the things that they're not telling you and trying to understand the process by which they're conducting the activities that you want to support with your design. After going through one cycle of the iterative design process, going through the assess, design, and build phase, you might come back around and say, okay, now that we have some ideas, some specific ideas, how does that compare with what else is out there? And you might perform a comparative analysis and go out looking at the other products that try to solve the same kind of problem and understand which ones work better and why they work better and which ones don't work as well. After another turn of the design cycle, you might be ready to perform some low fidelity user testing. So you might take a paper prototype, for example, and put it in front of users and ask them to perform some tasks and try to understand, again, what works and what doesn't about your design so that you can fix it in the next cycle. After the next turn around the iterative design cycle, you might be ready to perform a heuristic evaluation, which is a specific form of guideline-based inspection, where you can now take your design and say, okay, what are the aspects of this design that are likely to deliver a positive user experience, and which ones are probably going to lead to a negative user experience. And then after another design and build phase, we might be ready for high fidelity user testing. So now you have something that's pretty close to the final product that you think you might be ready to ship, and you want to iron out those last few details by putting it in front of users and getting their feedback and observing where it works and where it doesn't. And even after the design process has concluded, the user experience research doesn't necessarily end. So after a product has been released, it's common to set up an analytics process where you can see how people are actually using the product so that you can use that information to improve the product in the next cycle. And you might conduct surveys to ask people about their experience using the product, what their satisfaction level is, what works for them and what doesn't. In this lecture, I've introduced the three basic methods that we use in UX research: asking, observing, and inspecting. In future lectures, we will go into much more detail about specific ways that we do that through specific UX research methods. Hi, I'm here today with Matt Martin, experience architect at Ithaca. And we're going to talk about user experience and the user experience field with a focus on user experience design and what designers contribute to the field of user experience. So welcome and thank you very much for being here.
Thank you.
Yeah. So tell me a little bit about what you're doing at Ithaca right now.
So I work on a team with software engineers, quality assurance engineers, a product manager, and a visual designer, and then myself. And what I try to do is set up enough strategy and enough design work collaboratively with my team to kind of get that work ready for development. So I would say I spend half of my days in meetings and half of my days doing design. And it's very collaborative. So there's going to be some times where I'm heads down work, doing some designs or doing some research. But then there'll be a lot of times where I'm brainstorming strategy with my product manager, or working with a user researcher to make sure that we're going to set up the right type of user testing. And then my visual designer, who I collaborate a lot with, is in New York. So we'll sometimes do some screen sharing where we'll collaborate on a design, or I'll just start sketching on a whiteboard and I'll take pictures of it and send it to her and say, okay, I just created this really quickly. Can you, bring back something to me? And then we'll kind of collaborate that way. So it's like we have these pods of teams that, like I said, are blended, and then some, other times I'll meet with the whole UX department with other designers to find out, hey, what are you working on and how is it going to influence what I'm doing? Sometimes I'm doing parts of the site or some of our products that do touch each other, and sometimes I'm kind of on my own, or it's a product that's not touching other things. So.
Could you give us an example of maybe a project that you've worked on and kind of take us through, how it started and how it progressed through the different stages until it became, however it ended up?
Okay. So we needed to do a redesign of the strategy and research arm of Ithaca. So they had a website that was aging. But not only that, their business model and some of the programs had changed. So we needed to do a refresh on the website to kind of represent that new program that they were trying to focus on. and also to do a better job of having that website reflect their business objectives. So
Could you maybe just say real quick what strategy and research?
Yes.
The strategy and research. Well, who are the users and what are they trying to do with this website?
So primarily what the strategy and research arm does is they work with libraries and higher education, and they deal with administrators and librarians to basically get technology and libraries kind of like ready for the future.
Okay.
How does technology influence that? And one of their programs that they started to promote and that started new just last year is called Educational Transformation, which is all about how is education being transformed and how can institutions go along with it. So they do a lot of consulting.
Okay.
They write a lot of papers, case studies, reports, issue briefs, and librarians try to get all of that research because they give it away for free.
Okay.
In the hopes to sell some of their products. They do surveys, they do on-site consulting and stuff like that.
I see.
So what was happening was the website was had a lot of information there and it had all the reports, but it wasn't as easy to go from one report to another, and there wasn't really a way for the products and the reports to kind of intermingle.
Okay.
And so it was our goal to figure out, okay, where is the business going? How is the site working and not working? And how can we make it work better? So what I did was I interviewed all the directors and all the program directors and the marketing directors there at SNR, was what it's called,
Okay.
Ithaca SNR,
Okay.
Strategy and Research. And I did that with a user researcher, my product manager, and an engineer. So while we were doing that, we were taking notes and trying to figure out, okay, so this is how they look at their business, this is how they look at their users. So we had a pretty good idea of what to do next. And next was, let's find out what we're dealing with. I did a content inventory of the whole site. We started to look at the analytics of the site to find out how traffic was getting there and what was happening while they were there and where the users were leaving. Next, I did a comparative analysis. So I'm looking at all the different competition that they have throughout the landscape, inside their industry and outside their industry, just to see how it happens, like how the branding happens, how the interaction design works. So what people are going to expect when they go to the site, so that we're not doing anything that's too different or something that we can make sure it falls in people's expectations when visiting the site. So once we did all that, and kind of concurrently, we had the developers starting working on a framework. So me and the designer could start thinking ahead, and we knew that we were going to have to feed the developers, the real full site. But in the meantime, we wanted to have them just develop a slice of the site. So a working version of every single section, but it didn't go deep.
Okay.
It was just one kind of like layer.
So this would be software, and you're thinking of just having the different components kind of in place so that as you're doing the design, you could actually have a framework to sort of test things out and see how it'll work.
Exactly. That way there was a foundation there. We could see if things were working, and we could find out early on that, hey, this really doesn't work. But what we did is once we started developing it, we could see that it could scale too. So while the developers were doing that, I went back to the stakeholders and said, okay, you have a lot of categories here. You don't have much consistency on topics and the way you organize your research. So I set up a workshop to really work on their vocabulary and taxonomy of just their, their raw materials of their research, so that we could develop a good information architecture of the site and do faceted search. That made sense not only to them, but to the people that they're reaching out to. Once we did that taxonomy exercise, we didn't put it in the site until we did a card sorting task with actual users. So what that is we put it online, all these different topics and categories, and had actual librarians come to this this program or site to organize how they saw those topics and categories. Once we had that data back, then we could tell developers, okay, now we figured out how this is supposed to be chunked and categorized so that they could start building it. And that way it was scalable, and we were able to make sure that throughout the whole process we're getting some input from our users. So once we had that slice, we were able to start filling in the rest of the site. And one of the things, not only do we want to get librarians and other visitors to download their reports, but we also wanted people to sign up so that they would get news of, hey, the new report's coming out. So we experiment with different placements of where that sign up would be. And once we found the best place for it, based on a smaller set, then it's been released. Now we've gotten, I think it's gone up at least 20% as far as the last time I checked. Because
The number of signups has gone up by 20% since the previous version.
Exactly.
Okay.
Yep.
Excellent.
Yep. So it has been a success, and it really shows just by moving something on a page can really have a huge effect on the design, and the sign up rate was amazing.
Well, let me ask you a couple more questions about that. So, so there were a lot of different activities happening at the same time. So you had
Yes.
software development happening,
Yep.
A number of different research activities. What kind of things were going on with trying to figure out, what the site was going to look like, how things were going to be laid out, what was connected to what? What kind of things were you doing in parallel to kind of work out the design of the site itself?
So I tried to break down the navigation into two different, categories. One was the persistent navigation, which is what you usually see at the top of every page. It's the global navigation, the big buckets. But what I spent a lot of time on with the stakeholders was the contextual navigation. How is each object related to another? So an object could be an article, another object could be an event that they're hosting, and another object could be the person that's either writing the paper or putting on the event. So that way I had all these modules that could be interrelated so that when you're on a page and you're on an article, you know who wrote it and if there's an event coming up. And they also can point to, this article relates to this product that they have or this kind of consulting practice that they do. So that way, no matter when you're on the site, you're always going to another related event or even another related article. So you're kind of, instead of just going there, grabbing the paper and leaving, I set it up so you can explore. So you don't have to go up to the main navigation as an escape hatch or to do the exploration. It's more in context exploration, if you will. So I spent a lot of time doing that to make sure that people were staying on the site and learning as much as they can and, satisfying the user's needs of getting those papers, but also trying to help the business objective of, hey, let's get these people working with us and partnering with us. Does that make sense?
It makes sense. And so were you doing this through, I'm just trying to envision, like how this happens, right? So are you sketching? Are you making mock-ups in, a graphics program? Are you building, interactive versions of it? And how are you working through this, right? It's a complicated thing you're trying to do here with this contextual navigation. So, how do you kind of go from, I think this would be a cool idea to this is the right way to do it?
Well, I got a big piece of foam core,
Okay.
and I got a bunch of sticky notes. And what I did and the reason I put it on foam core is I wanted to work collaboratively with one of the developers to say, okay, this is what I'm thinking. And then I also wanted to work with a stakeholder that was living she was either in New York at the time or one of the Carolinas at the time. So what we did is we put one computer on the board and we moved sticky notes around, right? Like I kind of seeded it and say, hey, this is how I'm envisioning it. But since she's the marketing director, she's responsible for a lot of the content, a lot of the editorial workflows. All the research goes through her and then gets populated on the site. So she really had, she was like a subject matter expert on what's happening in the organization. So, and then I've got the developer there just watching and seeing this because he's starting to estimate how much this is development time it's going to be, and if the platform we're putting on, I think we started with a WordPress site, we wanted to make sure that it was feasible. So that way, because it was sticky notes, it was never set in stone, and no one thought like, oh, if it's in a spreadsheet, it's it's locked in. It's like, no, it's not locked in. Let's do a collaborative exercise where we're moving sticky notes around. That was mobile, so I could move it to a different office. I could take a picture of it and send it to other people to kind of get
mobile, because you could just take the foam core. And,
Yep.
Yeah. Okay.
Exactly.
Right.
Yeah. I could move it around, and then once I had those modules and objects kind of figured out, I then went into a wireframing, vector-based OmniGraffle and started laying out how these things would look on a page, but also how they would interact and how they were sewn together. Once I had that, I made it a clickable prototype, not for users. That would have been great if we had that kind of resource and timing, but we felt we did a good enough job in the strategy phase. We felt this was good. It was really just to show the stakeholders, hey, this is how we're now envisioning your site. So they kind of had a preview before we got into look and feel. Because at the same time, our visual designer was hired a photographer to get some shots so that wasn't stock photography, was something that was more in line with their brand, because she also wanted to kind of re-envision the brand. So she was she was thinking about different, concepts of color and how that color would work on the site without taking too much attention away from the articles. So kind of like I'm doing the interaction design while she's kind of doing the visual and emotional design at the same time. And we're collaborating to say, okay, this is what I'm thinking here, and she's saying, okay, this is what I'm thinking here. And then we're presenting that. What was really great is in previous, engagements when I wasn't inside and I was at agencies, it was like we saw the client every once in a while, and we would have these big deliverable dates. Where here, we said we want to meet with you at least every other week to show you our progress. We're never going to these are never done states. We're not having you sign off on it. We just want to show you what we're working on and have you collaborate with us. And I felt that was a really successful way to do it, but not. I think that's a best case scenario. You don't always have these high level directors of companies that you can talk to twice a week.
Right.
Or I'm sorry, every other week.
Right. So, but that's very interesting. So you're thinking very much about creating these artifacts that will facilitate certain types of communication, right? Communication with the subject matter expert, trying to make sure that you get it right. Communication with the stakeholder to show progress, and also thinking about what kind of communication you want to have. So it sounds like you separate out conversations about the interaction design from conversations about the look and feel and the typography and the specific images and the colors and things like that, so that you can have these kind of focused conversations.
That's exactly right. I tried to make sure that I wasn't painting us in any kind of corner and allowing the stakeholders to have their say, but at the same time not having people get hung up on, I don't really like the font or the colors that are happening here, and they're not paying attention to the interaction design or some of the content strategy. So we really did have to divorce certain things and present certain, kind of slowly reveal things to people so we could get the right conversation or the right kind of feedback. So, and sometimes a sticky note and some crude drawings are just enough, just to set the direction.
To keep it focused on that particular topic right there and not get distracted by these other things. So it sounds like this story has a happy ending. You talked about it, the product. It sounds like was released. You have some data that it's been successful in some ways, and so congratulations on that.
Thank you. Yes.
Excellent. So I know that before joining Ithaca, how long have you been at Ithaca?
3.5 years.
About 3.5 years. But I know from talking to you previously that you've done a bunch of other things as well.
Right.
So I think it'd be great to just hear about what your career has been like, and what how you got where you are right now.
Okay. Well, I guess we can go back just before I went to graduate school. I was a photographer, and I was in a research hospital, and we had a lab that was half chemical processes and half digital processes, because this was the 1900s, so 1990s. We were still doing a lot with film and chemicals. But I saw that the digital mediums and computers, and especially with the beginning of the internet or the web, photography was changing really fast, and it was becoming more digital. That's when I decided to go to graduate school for human-computer interaction at the School for Information. So while I was there, during the summer, I got an internship at an agency actually doing what they called usability engineering, which was user research and doing design work. And I worked with visual designers and front-end developers. This was the year 2000, so during that time, the dot-com bubble burst, so the internship that I was hoping was going to lead into full-time employment was gone. So once I graduated from the School of Information, I went to Wayne State University to become a digital librarian. So at my time at Wayne State, it was a wonderful time because we had a grant called the 21st Century Librarian. So we had money to do special projects and fund graduate students to do the work. And some of that work was working with the Detroit News photo morgue. So we had images going back from the 1800s up until about 1980. We're digitizing all of those images and associating metadata with those and then putting them online for access. The other fun project was working for the Detroit Historical Museum and looking at their toy collection, primarily toys from the early 1900s that were wind-up toys, and putting those online to show people how they work. We actually got a lot of traffic from industrial designers that saw that and kind of used that as inspiration for their work. While I was a digital librarian, I wasn't really doing too much UX work. I was mainly working with professors or different libraries or different archives and my graduate students, which was a blast. But I also really liked to do design, user experience design. So I did some freelance for some agencies. And then one day, one of the agencies that I did work for, offered me full-time employment. So I started to go down that road.
Okay.
It was a very large agency, so I kind of it was cool because it was a print agency that was trying to figure out how to do digital. So I felt it was a cool kind of time of flux. But as things kind of progressed, I realized that I don't want to be at a huge agency, especially an old school agency. I kind of want to be at more of a startup feel.
And an agency, just to be clear, is a company that sort of does projects for external clients.
Exactly.
So you would be doing, you might have a retailer one day and a manufacturer the next day, and
Yep.
a taxi company the other day, and you're doing different. I mean, I'm making this up, but you're doing.
So,
You're
no,
getting to do a lot of different types of projects and design work.
Absolutely, and that's what was so fun is I usually had, two concurrent projects happening. One would be for like a wireless cell phone company and trying to figure out, how they're going to sell those products. And then the other thing might be doing a pitch for some kind of weird branding thing that we're going to do like in the physical space. And how does that physical space relate to something that's going to be on the web? So it was always, one thing was inspiring the other, and it was always like really fast design work, work with a lot of cool people, but it was pretty. I'm not going to say it wasn't stressful. It was a lot of work all the time.
Yeah.
Especially at a big agency, you always have these huge clients. I mean, the government, you got the Navy, the United States Postal Service, and then healthcare. We worked in a lot of different verticals. So financial services, healthcare, e-commerce. So you never know where you're going to be, but you learn a ton all at once. But like I said, I wanted to go to a smaller agency that was more of a startup, and found one where they really understood digital. They actually just were only digital. They had never done print or anything like that. But while I was there, that's where I really got my e-commerce chops, because we had a user research team and a user experience design team. So what would happen is we had our own usability lab in-house. So when people were going through the e-commerce experience, shopping, and then going through the shopping cart, we were able to optimize every step of the way. And while we were studying and testing that, we could, between participants, between users, we could actually change the interface and tweak it so that we could really start dialing it in and get some of those gotchas out right away, and then start to validate that design as we went through.
Okay, so very tight integration between research and design.
Yes.
Yeah.
Though they were, we had separate disciplines, because before I was kind of like, I was my own researcher. I would have to go to, or I wouldn't be able to do the recruiting. I would farm that out, but I would be running my test. I would be creating the test, etc., which could have some ethical implications as far as, am I objective when I'm testing my own designs?
Right.
So it was good to have, someone that was like, okay, I have no skin in this game.
Right.
I'm just going to test it for you.
Yeah.
So that was pretty cool. And where I'm at now, we actually have a user research team that does, goes out there, does observations, does ethnographic research, but also we have a usability lab here at Ithaca. So it's still, we kind of keep it separate, yet we're tightly integrated. I meet with them probably every other week so that they stay ahead of my recruiting needs or testing design needs.
So I'm going to ask you for one kind of parting thought,
Okay.
which is for folks that are just starting out, maybe just looking at UX as something that they're thinking about getting into, maybe thinking about, moving towards a career. Do you have any advice?
Absolutely.
Okay.
Look at everything in your environment and try to think about why it's there and its purpose. So I have a child, and it's great to look at his toys to think about, okay, what is its purpose? Does it communicate that purpose, and do I like it? And so it really helps you influence of how you can think about an experience. Like this glass, for instance, it has a purpose of, it has to be a vessel to carry some water, right? But there's a lot of things you can do to it. You can add color to it. You can have different shapes. But, for instance, it's not a bigger vessel because you got to hold it with your hand. So it's kind of like, think about that when you're thinking about your phone. You have to use it with your hand, and there's a certain amount of interaction with it and experience. So anyone that's kind of thinking about getting into experience design or something like that, it's fun to kind of just critique things around you, because then you can start thinking critically about design and why people create things. And then it really helps you influence when you're in the digital realm. You can kind of do anything you want when you're not in the physical realm. So I like to kind of juxtapose those things together.
Excellent. Yeah, so kind of taking a designer eye view
Yeah.
of the world is something that you can just do throughout your entire life.
Right,
Yeah,
exactly.
excellent.
And try to focus on the positive things and the things that make you feel good, because a lot of times, I could critique a ton of things that make me frustrated. And a lot of times that's what,
Right.
a lot of users feel that too. It's like, I'm so frustrated, we've got to make this better. So, but
So
yeah,
find some positive examples. too.
Exactly,
Excellent.
exactly.
Okay. Well, thank you very much. This has been great, and I really appreciate you taking your time to chat with us.
absolutely. Thank you.
Hello, I'm here today with Leah Hogan, who is currently the Director of Enterprise Research Strategy with User Testing, which is a new role for you, if I'm not mistaken. And I'm going to chat with Leah about her experience in the world of UX research, kind of what she's up to and what she's been up to, and what it looks like to work in this field. So welcome, and thank you for being here today.
Thank you.
So yeah, tell me a little bit about what you're up to now and what kinds of things have gotten you to where you're at.
So right now, what I do is work with user testing customers to basically get the most out of the platform. And to back up a little bit and just explain what user testing is, it is essentially a large panel plus a software platform that enables video and audio recordings of what's happening on screen, so whether it's a desktop or a mobile device, and then a microphone to let different organizations, whether they're business, government, entertainment, gaming, get an understanding of how it is that people are experiencing their digital products.
So it lets a UX researcher run user tests with people who are remote, who are far away.
Remote, far away, and asynchronously. So we can also do moderated usability tests as well. We do those as well. But it's really a great thing for our customers because it gets around some of the constraints that doing in-lab testing imposes. So you get a natural setting because it's people using their own devices. You get people who kind of represent a broad range. So the panel is very large, so you can get anybody from stay-at-home parents with 3 kids to a college student, to somebody who is older. And so it's very hard to get access to panels, and people spend a lot of time trying to do that in their work. So it's a bonus benefit.
Very cool,
Yeah.
very cool. And so what kinds of things are you focusing on?
So I focus on really actually helping people to understand, both at a high conceptual level, what sorts of research they should be doing. So what types of questions they can be asking, and then what methods they can use to answer those questions. And just kind of evangelizing around how it is that you share that information with your internal clients, your internal customers, as a researcher, so that they really understand what needs to happen based on that feedback.
And so, as I mentioned, based on our earlier conversations, this is a relatively new role for you, and so it's a more strategic role. You're really kind of looking at, how to apply these tools. But I know that in your earlier in your career, you have been and were more directly involved in some of the UX research methods and actually conducting the methods and the studies yourself. And so I wonder if it would be possible for you to think of maybe a project that might be, I know there's really no such thing as a typical UX research project, but one that might be, a good example to help us understand, what it looks like to go through one of these projects.
So earlier on in my career, and this was probably about, 15 years ago or so, I worked on a project for Siemens, their power transmission and distribution arm, which essentially is the group that's responsible for building and maintaining nuclear power plants.
Sounds important.
Yeah.
Okay.
So I was actually doing this research in Europe, primarily in Germany, working with a system that they had internally built to maintain content both on the website as well as in their paper resources. And so what they were really focused on was optimizing the back-end experience to enable people who were not nuclear engineers to maintain information about replacement parts for nuclear power plants.
Okay.
And so as part of that, I did interviews. Really it was kind of trying to answer the question, how do we get non-engineers to be able to understand enough about the information that they're inputting so that they're doing it the right way?
Okay.
So I did, interviews with nuclear engineers and non-nuclear engineers in Germany, Denmark, and Spain, because it's an international business. And I also took to those interviews essentially prototypes of a different approach to actually entering that information. So they actually built it, and I was coming in to help them to refine it. And so basically the deliverable out of that project was a recommendation on both what the changes to the tool might be in order to make it easier to use, as well as process recommendations around how would they be able to manage that information in a better way. And so it was a little bit of both research as well as design work. And I think that happens a lot, actually, because you're asked to be able to answer both types of questions sometimes. Yeah.
And so in this case, there was an existing tool, but it wasn't so much about testing whether that tool was the right tool or whether it was usable and things like that.
It was, to a certain extent. We assumed that it wasn't as usable as it should be because people weren't using it the way that they should be. And so it was really saying, okay, starting from the premise of we need to improve this experience, what do we do to enhance it?
Excellent.
Yeah.
So that's a good example, a great example of a UX research project where you have a problem, in this case maybe a tool that isn't performing as well as it should be, and the question is, why isn't it performing and how can we make it better? What else?
What other sorts
What
of
else
things?
is there, right?
There's a lot. I mean, obviously. So some organizations have a built-out system that they're really trying to optimize over time. And so in my previous role at 4C, a lot of what we did was basically help people understand what their customers' perceptions were of the site using what's really called attitudinal analytics, so surveys.
Okay.
And match that up with behavioral analytics, so clickstream data, and as well heuristic evaluation, saying let's bring an understanding of user experience best practices to the equation and say, we know that people are saying they have a problem here, experiencing a bottleneck there based on the clickstream analytics. Let's bring to bear those principles that we know work and see what we can do in terms of helping you to optimize that experience, giving you recommendations and very specific ones on how to fix that experience.
So these would be examples of sites, probably mostly websites, but could be potentially other products that are already out deployed, have lots of users, and the question is, how are people responding to it? And if it's not working, or if there's some signal that's telling us that something is not optimal, what is that, and how can we go and fix it?
Yeah.
And using multiple methods, surveys, the clickstream analytics, and also heuristic evaluation to try to pinpoint what those problems might be so that you
Yeah.
can fix them.
Primarily, yes, but we also did work with prototypes too. So
Okay.
we'd say, we want to add a new feature or function. We don't have all that data. So it really is, how can we optimize this experience based on those principles, those heuristics? And the same ones that we would apply to an experience that already exists. So, I find that, there are a number of heuristic systems that are out there because, humans experience the world in a very consistent way. I mean, our bodies work a certain way, touch works a certain way, your eyes are structured a certain way, so you process information that way. And so relying on that knowledge of how people kind of work, you can usually get to a lot of the right answers, even ahead of testing a prototype.
Just by knowing the principles of how people work and how that translates into what designs are likely to work and not likely to work.
Yeah. So that's, I think, a lot of fun. I think some of the other really fun stuff that I worked on, I really find that kind of bringing different methods to bear is probably going to help you get to the answer more effectively than just one.
Okay, can you say more about that?
Yeah, I think when you have a user experience problem or issue or question that you're coming up against, there's usually more than one way to answer it. And sometimes you have to answer it using more than one method. Some of it is getting people to directly experience the product. So just putting it in front of them and saying, use it. The products evolve over time. And so the questions that you ask when you are just trying to concept something, like, let's say you want to build, a new mobile app. Well, we don't have actually a whole set of design patterns for mobile apps right now. We have some evolving best practices around how to do it, but it really is almost an open playing field right now. So you can go out there and innovate and say, wouldn't it be cool if we tried doing this and putting that in front of someone on paper?
I think there's a lot of excitement in emerging areas like the Internet of Things and wearables, where really there are very few patterns or established practices that can guide you.
Yeah. And it's also a challenge actually doing testing in those environments because we haven't even created a set of tools to really test creatively wearables, for example,
Right.
Yeah.
User testing is not on your watch yet. Right?
It's not on your watch yet at all.
Right.
Yeah.
Yeah.
And I mean, and not only that, but even trying to capture that in a lab setting is challenging because, you might ask someone to actually take it off of their arm so that you can have a camera directed at it, for example.
Right.
So I think we've got some evolving to do around how it is that we test those types of experiences.
But as you were saying, in some other areas like the web and in desktop software, we have decades of experience and we
do.
have some good patterns for how things ought to
Yeah.
work. Not to say that there aren't innovative things that we can do,
Yeah.
but we have more knowledge about what works and what doesn't and
Yeah.
how people's capabilities interact with those platforms.
Yeah. That's very true.
Yeah.
Yeah.
So I guess just one last topic I'd like to explore with you. For folks that are just getting started in UX and maybe thinking about directing their career in this direction or incorporating it in some way, what advice might you have for these folks?
So the first thing that I would say is, and I say this to people everywhere, there are not enough of us.
Okay.
So if you decide to get into the field, it's there are a lot of opportunities out there because a lot of people are innovating and building new things. And even when they're not innovating and building new things, they are trying to make what we have better. And there's a recognition in industry, especially, but in education, in government, that designing systems and products for people makes them more successful. And bringing people into the equation that come from the perspective of understanding what the principles are to make successful products and services is going to help you to make things that are better. So I think there are a few things. One is there are a lot of people who come into the profession having had some experience in some other field. So whether it's graphic design, whether it's being a developer, that kind of background is actually very useful because it gives you an understanding of what the constraints are in those areas as well. And I should say constraints as well as opportunities.
Well, I'll just add to that, having taught at the School of Information for a number of years, people are coming from a huge variety of different backgrounds.
Yeah.
Music, history, literally every corner of the academic universe, people are coming to this end professional universe.
Yeah, and so I'd say don't think of your background as being something that's going to hold you back. It will really only complement the work that you do moving forward. And most people tend to combine something of their background along with this interest in human-centered design and research. I think that it's really important to stay curious. So in addition, and I really do think it's important actually to get some formal training in some way. And that is because there are these principles that you should be aware of that are grounded in psychology and ethnography. And you should be aware of that. And a lot of organizations are actually looking for that type of experience and background when they are looking for people to join their teams.
And let me just follow up on that and talk about the growing need for UX, which I absolutely agree is something that is just becoming ever more clear that we need more people doing this kind of work. I'd like to hear your thoughts a little bit on how the industry or the industries are evolving and what where that knowledge of UX is coming from and how that's shaping up and how it's sort of differing across different organizations. I know you've had a lot of experience working with different companies, and you've seen different ways that UX is being incorporated.
So I think a couple of things. One is that some of the respected research organizations that are out there are basically saying people are winning. The bottom line, and I say this in the business context, the winners are those who actually have a superior customer experience, which is really grounded in a superior user experience. So we're talking about, the Amazons and the Apples and, the Facebooks of the world. They have very significant resources that are all about making the user experience great. So they have big design teams. They have big research teams. And, they are focused on trying to make their products usable by a lot of people. Because if they're not usable, they fail. And if they fail, then they don't make money. So it really is, it's a focus on the bottom line for a lot of businesses right now. And they understand that they're competing on the basis of customer experience. Forrester just last month released their most recent customer experience survey. And, just even looking at that list, and knowing in the back of your mind what those companies are, you can tell, the good ones from the ones that are struggling a little bit more.
This has been great. Thank you
Yeah.
very much for taking some time to sit down and chat about UX research and various other topics, and
Right.
appreciate it very much.
You're welcome.